Good afternoon. I'm really el-Khoury, Dean of the School of Architecture. I'm honored to be here today to welcome you to our 2022 Smart Cities Miami Conference, jointly hosted by University of Miami's Institute for Data Science and Computing, IDISC, and the School of Architecture. The conference isn't strictly academic forum. Smart Cities Miami, as the title indicates, is about smart city phenomenon in Miami, in our city, in real-world applications, in partnership with government entities. This is a forum for our larger community, entrepreneurs and innovators who are reinventing Miami as an incubator for tech startups, development and planning agencies in the public and private sector that are guiding the evolution of one of the fastest growing cities in North America. We are interested in this forum because we believe we are at the threshold of significant transformations in the urban environment, evoked by new services and practices, driven by new technology. We have witnessed the disruptive power of the lives of Uber, Airbnb, but wait until we have here fully functioning self-driving car, or all kinds of new disruptive technologies that are sure to change the ways we inhabit and manage our cities. I am thinking today in particular of this year's conference theme, meaning the technologies that were deployed and accelerated during the pandemic. The smart systems that delivered healthcare at home, the intensified investment in extended reality. We have been anticipating the transformative power of augmented and virtual reality for many years, and actually Ronnie Abowait's magically famed delivered the keynote speech here in 2019 and gave us a glimpse of that future. But it wasn't until we saw during the pandemic these technologies deliver click presence, immersive experiences at home that it's not until we saw them in action what they can do that education, business, and entertainment are now fully embracing extended reality. So, are we to expect major disruptions in how we learn, work, and play? Is the decentralization of work and commerce away from the business centers that was anticipated, by the way, with every development in telecommunications? Is it finally happening as we see the workforce reluctant to go back to the office downtown? The three panels this afternoon will address this and other questions pertaining to technology and the city after the transformative impact of COVID-19. We kick off the conference with Skylar Tippett, who will share with us his visionary projects from Boston to the Maldives, and conclude the formal program this afternoon with Margaret Brisbane, who will bring us back to Miami for some very present matters. After Margaret's talk, we shifted to full expo mode and moved across the breezeway to the exhibition space where exhibitors are showcasing their technology and services. By the way, the expo is open all afternoon. Longer there if you wish, but you will be sure to meet the presenters at the reception and networking I would like to thank Concreto for their generosity and vision in supporting this conference, but also the ongoing research in the newly established unit. Also many thanks to our bronze sponsors, Valmir and DDS, CAD, Digital Drafting Systems. I would also like to recognize Janina Bianchi, el-Khoury, Karina Alvarez, Janelle, Karina Shahid, and the rest of our IS/SOA team for putting all this together. Thank you for the great work. And now I'm delighted to introduce our keynote speakers, Tyler. He is the director and founder of the Self-Assembly Lab at MIT's International Design Center. He is also an associate professor of design research in the Department of Architecture, where he teaches design studios and coordinates MIT's undergraduate design programs. Skyler was named R&D Magazine's 2015 Innovator of the Year, 2015 National Geographic 2014 inaugural Wired Fellow. Go on and on, a long list of honors. Suffice it to say that he's on a stellar trajectory and is widely recognized for groundbreaking innovation in the field. Please join me in welcoming Skyler to this.
Pleasure to be here, and great to see a few familiar faces in a slightly warmer climate than Boston, although we're getting to be the next weather there. I'm Vasiliu-Feltes, I'm a faculty at MIT. I run a research lab called the Self-Assembly Lab, but I thought I'd give you a bit of broader context before diving into the research. Outside of MIT, one of the things that I run is the 3D Printing and Additive Manufacturing Journal. And it's an interesting place because it brings together all sorts of researchers, academics, professionals, looking at all things additive, the future of additive manufacturing. And so you get material science, computer science, biology, architecture, design, etc. Closer to home, these are some of the recent publications that talk about our work, and I'll try to go through that today. The lab, as I said, is called the Self-Assembly Lab. And what I want to talk about is really rethinking the aspect of smart. What do we think things mean when we say smart, like smart cities, as today's event is focused on, or smart materials, or smart construction, smart homes, etc. Our research lab is made up of roughly 15 people, from undergraduates to masters, PhDs, full-time researchers, a lot of different backgrounds, many of which have some type of design architecture degree, many of whom have other degrees, mechanical engineering or computer science, material science, etc. And as I was saying, we're really interested in challenging this notion of smart. What do we think about when we think of the future of manufacturing or the future of construction? And I would argue that most people think of this. We think of industrial robot arms, more and more automation, more and more mechanical reproducibility. And there's a similar notion, what do we think about smart homes, or smart products, or smart cars, or smart shoes? Specific to homes, we often think about smart devices. And I'm going to try to shift that away from a device and more into the environment and materials. We're really interested in trying to embed intelligence, agency, capabilities in simple everyday materials and their relationship to the environment, whether that's wind, waves, energy, temperature, you name it, different activation energies in the environment, or fundamental materials like wood, metal, plastics, foam, sand, rubbers, really simple things, and trying to advance those into what we might call as intelligent or smart systems. How I got into this is looking at the history of computing. I have a background in architecture, and I became really interested in computation as a design generator. This is the first CAD tool developed at MIT. This is Sutherland's SketchCAD. that obviously led to lots of computational tools. And we're seeing computation explode in every industry. It's enabling more and more design, generation, creativity, optimization, you name it. Computation is ubiquitous today. And there's a similar parallel if you look at fabrication. This is the first CNC tool. 1955 at MIT, the first time they connected a computer to a milling machine to create what they thought as automation for fabrication. And that then led to all sorts of digital fabrication, from the industrial robots that I showed before to 3D printers, laser cutters, water jets, you name it. There's a trajectory of machines and computing working together for fabrication. And when I came to MIT, I was really embedded in this world. I was really interested in code as a new language for design, code as a language to fabricate and make things, and we often hear of mass customization. And I was sort of drinking this mass customization Kool-Aid that you could computationally generate anything and you get free complexity when you fabricate it. You know, the machine doesn't care if it's one shape or another shape. There's really a minimal cost in any difference in the geometric complexity. But then I started to look at the assembly process, that if we have code for design and we have code for fabrication, what would code for assembly be, or code for construction? Because most of the time, yes, we can fabricate really complex geometries, but it comes down to manual labor, or you have a logistics problem. Because you have all sorts of different parts, it becomes a three-dimensional jigsaw puzzle, and not a lot of people are focused on that last part, or the last mile problem. How do we actually assemble these more and more complex things? When I was a grad student, I was under Neil Gershenfeld's lab, the Center for Bits and Atoms, and we had a DARPA grant called Programmable Matter. And this was about a decade ago. Programmable matter at that time meant robots, basically smaller and smaller robots, bigger and bigger robots, put robots in everything, and you can make everything programmable. And we were making these large reconfigurable robots. But over time, I started to question that. Probably coming from the architecture world, you don't want to build every brick out of a robot. You don't want every single thing in your environment to be robots, not to mention the ethical consequences of that, but just the material, the energy, the cost, the assembly, the potential failure. You don't really want to scale robots in that way, but you do want the programmability and the intelligence. And so we became focused on how to embed more intelligence and agency in materials without the electromechanical devices. And our lab looks at this human scale world, mostly for two reasons. One, if you look at the process of self-assembly, self-organization, or what we call programmable materials, most of that happens in biology and chemistry. There's lots of different researchers around the world that focus on that at very, very small scales. And so our lab is unique in that we focus on this at large scales. But I'm also interested in these human scale processes, whether that's shipping, packaging, logistics, to manufacturing, construction, because the human scale world is very different from the rest of the world. If you look at very, very small scales, like I just said, or even skip over the human scale, go to planetary scales. No one's 3D printing a planet. No one's fabricating a mountain. These things assemble themselves. And we became really interested in how design and construction happen from the bottom up outside of the human scale world. So in our bodies, design and construction build humans. In mountains, oceans, weather patterns, planets, self-assembly is the primary driver. And so we became interested in how does that translate to how we know to build today? Is there another opportunity to build intelligence in our materials? So there's three main research topics of the lab. The one I'm going to start with is what we call programmable materials. The idea being that we want to program physical materials the same way that we do with computers and robots. We want to embed agency, sensing, actuation, logic in those materials. And the way that we do that is we look at these three ingredients. So we look at the material properties, whether that's wood or plastic or rubber or foam, and we try to link up that material property with some type of activation energy. So if you take wood, we know that wood's going to swell with moisture. Or if you have temperature change, maybe you're going to use a polymer, or you're going to use a metal because you know there's going to be a difference in coefficient of thermal expansion. So you can link up that material property with some activation energy. But the reason I say geometry is because we use different forms of digital fabrication, whether that's printing or lamination or routing or weaving or knitting. We use fabrication to create two-dimensional and three-dimensional geometries. Sort of like Braille, it's the geometric information embedded in the material. Or in DNA, it's the ACTG. It's information and code in material properties through geometry. And that allows you to get things that transform, sense, respond. They have agency. They have a behavior that they wouldn't have otherwise. And all of this started with our work on 4D printing. The idea was that we would take 3D printing and we would add the element of time, that we wanted to print things that transform, they reconfigure. They're just like the robots I was talking about before, but it's just simple materials. We could print the agency into that material. And we did that originally by printing 2 different materials. The black material is just a rigid polymer. The clear material in the joint is a hydrogel, and that hydrogel swells with moisture. So you print these structures, and we have different geometry, different quantities of material in the joints. And when you dip them underwater, then they transform on their own. So a line folds into a cube, or a line that folds into the letters MIT, or a surface that transforms into a truncated octahedron, or a flat sheet that creates curved crease origami. And all of these are looking at different mechanisms: folding, curling, stretching. This one's expanding and contracting, so you have a flat sheet that can form itself into doubly curved surfaces without any manual forming or stretching in a robotic way. The material has that agency in it. And after this work, the same question kept coming up. Well, this is great, but how do we do it without plastics? How do we do this without 3D printing? Can you do it with any material? Can you do it with other manufacturing processes? And so since then, that has been about 1/3 of our research, just focusing on lots of different materials, lots of different applications. So we've worked on things like wood that morphs based on moisture, or carbon fiber that folds based on temperature. This is the first page of our book in Active Matter. It's films that expand or contract based on sunlight or 30 to 40 Celsius temperature change. So we made these stickers that can go on facades with Google, and they can transform based on sunlight. We made interior partitions that open and close. This is some auxetic work, so those films turned into sort of macro scale textiles that expand or contract uniformly. And that then led to a grant through Advanced Functional Fibers of America, where we made textiles that morph based on pH and moisture, or in this case, temperature change. So we can do this with lots of different materials, lots of different manufacturing processes, and all of it is about embedding that information directly into the geometric structure by tapping into material properties. And so these textiles, they can expand or contract to change porosity or to change thickness, so you get different insulation values or create vents and flaps. And then more recently, a lot of that research was with Ministry of Supply. It's a clothing company, MIT spin-out, and at the beginning of the pandemic, that then switched, so they changed all of their manufacturing towards masks. And one of the advances that we started to push on the research is the customization aspect. So we all know that masks, it's important for them to fit well, but everyone's face is different. And this translates to anything you can think about: shoes, socks, clothing. You know, there's standard, small, medium, large. But there's this constant battle between customizing and personalizing versus mass production. And so what we showed with the mask, but again, this could be translated to lots of different things, is that you can still mass produce. So you can produce standard objects, you have the efficiency and scalability, but then we take 3 measurements of the face and we can morph the textile to be perfectly tailored to that person's face based on just 3 physical measurements. And then more recently, we started working on spacesuits. So I'll let this play and then talk about it. So that project was with David Newman and a bunch of other researchers at MIT looking at spacesuits, because there's a big challenge. Most spacesuits have up to 7 or more layers with different functionalities. And given what I was talking about before with industrial knitting, we can embed multiple functions into that knit spacesuit. So it can sense, to control, or to tell you about the movement. It can then sense the compression, because mechanical counterpressure is really important in space. And so on. So you can embed that directly into the functionality of the textile. So the second topic of research that I'll talk about today is phase change. So we're interested not only in materials that change shape, but how do materials change phase? So going from solid to liquid or liquid to solid. And one of the printing processes that we developed initially was called rapid liquid printing. A lot of this work came out of the original 4D printing work, and we were sort of frustrated by the challenge of existing off-the-shelf printers. You have either like really high-end black box machines that you can't hack, manipulate, change the properties, or you have really low-end machines that are often open and accessible but don't have great qualities. So we developed this new liquid printing process with Steelcase, the furniture company, and we were trying to challenge the 3 problems with printing, so speed, scale, and material properties. And we can print very, very fast at large scale with traditional soft industrial material. So there's no, quote unquote 3D printed material. It's the same, in this case, silicones or foams or rubbers that they print with traditionally. We print inside of a vat of gel, which eliminates the gravity. So we can print in 3 dimensions without any support materials. You can print layer by layer in this case, or you can print in 3D. You don't have that effect of gravity. We can print with elastomers that have up to 1,000% elongation, so super soft, stretchy materials. That allows you to then print multiple chambers to create behaviors like these soft robotic mechanisms. We've developed a lot of different systems. This one specifically was with BMW, looking at the future of the car interior. So it's imagining a future where there's a cushion-like system that can provide both the lumbar support. You could change the stiffness of that, like changing how soft or hard the seat is. You could have massage features, maybe even crash protection. One system that can morph and transform for all of these different functions. And so that was printed in that process. But we've worked on a lot of other things, from footwear to home goods and lighting to medical devices and prosthetics. And then most recently, we spun that out into its own company. In the lab, we then took the research further to look at high temperature materials. And in this case, we print with molten metal. So it's almost the same game, but instead of gel, we print into a powder vat. That powder eliminates the effect of gravity. We print with high temperature molten metal. This is even faster because there's no cure rate. So we can draw in 3 dimensions. With molten metal, you can then take it out in seconds, and you can print meter scale objects in this way in seconds to low minutes. The other thing that's super interesting about it is 100% recyclable. So everything we print, we can then melt back down, print again, over and over and over again. There's almost no waste, and it fits directly into the existing recycling stream if you're printing with aluminum, for example. So that's one of our big focuses right now on the printing process. Another research topic under phase change that we look at is called granular jamming. So granular jamming is just a phenomenon where particles jam and they get stuck. And when they get stuck, they act like a solid. But if you leave them room, they can move around and behave like a liquid. And you'll notice this when you're at the beach and you jump on the sand and it hurts or it's solid, but when you play with the sand, it's soft. That's granular jamming. With a group from ETH Zurich, or Maurizio Kohler's lab, we developed this technique of granular jamming with rocks and fibers, and that promotes load-bearing structures. So we did this project called Rock Print at the Chicago Architecture Biennial. There's a yellow bounding box, and we're spitting out string and putting layers of rocks. So rocks and string over and over and over again. And when you remove the yellow bounding box, all the rocks fall away that didn't have string, and only the rocks that had the string jam. There's no adhesive, there's no connectors, there's no fasteners. It's just rocks and string. The string takes tension, the rocks take compression, and they get stuck, so they become load-bearing. And then at the end of the exhibition, we can wind up the string, and the whole column can disintegrate back to a pile of rocks and a spool of string. And the reason this is interesting is because it's like reversible concrete. So concrete is great, it goes from liquid to solid. There's all sorts of environmental issues that we can talk about. But one of the biggest problems is it takes a long time to cure. It can be 28 days
to cure before you can use it, and that costs a lot of money, that costs a lot of time. In this case, it's instantly solid, and it's 100% recyclable, so you can do it over and over and over again with no waste. So we're really interested in that as a sort of new perspective on construction. And then the last topic of research that I'll focus on is self-assembly. So the lab's name is the Self-Assembly Lab. We're interested in the phenomenon of individual components that come together on their own to build ordered structures without humans or robots. So you can see this everything from biology to mountains and weather patterns. There's all sorts of interesting phenomenon where things self-organize. And we've done a lot of research in different environments, different scales. This one where there's components that assemble into a chair underwater. Each part was a unique geometry. This one is with weather balloons, and they have Velcro nodes, and they tumble around. This is the courtyard outside of our lab, and there's fans at the bottom, and there's people pushing them up, and they assemble into cubic lattice structures. We've done this at a bunch of different scales, different materials, trying to experiment with things like what happens if you change the shape of the geometry, what if they're predetermined, what if they're non-deterministic, how big or how small can they be, what about different activation energies, water, wind, et cetera. But up until a few years ago, we saw a lot of this research as our basic research or very academic research. People would be like, oh, well, when are you going to build a building with weather balloons? How scalable is this? And we were interested in the academic questions, like what's possible, how fast can it be, how large can it be? But more recently, we were approached by a group in the Maldives to translate some of this research and address the challenges they face in terms of sea level rise, beach erosion, et cetera. And the Maldives is an island nation. They've got a lot of press over the years. There's an amazing documentary called The Island President you can watch, and they're really at the forefront of climate change because they're going to be one of the first impacted. I mean, Miami, New York, Boston, all of these places are going to be impacted by both sea level rise and erosion. And there's not really a great solution. The only two solutions today, one of them is to build static, hard infrastructure, man-made structures like breakwaters, jetties, walls. The problem here is that a static solution is never going to win in a super dynamic, complex environment like the ocean. The best case scenario may work for a few years. Worst case scenario amplifies the effect, or nature is going to always win. The other common approach, and you'll see that anywhere, here in Miami or Key Biscayne, all the way up down the East Coast, island nations, everyone uses this, which is dredging. And dredging is super harmful, it's super energy intensive. You suck up sand from the deep ocean, you pump it back to the beach, but it's really a Band-Aid solution at best. It doesn't solve the problem. They do the same thing in the Maldives. It's obviously an economy built on tourism, so they can build a new island in about 30 days using dredging. But that island doesn't want to be there, so they have to keep dredging year after year to keep the island there. We became interested, though, in about the same amount of time that it takes them to build that island, there's a number of islands that build themselves. And so these are large formations of sand. This is one of them. You can park a boat on it. Locals will go there and take over the island for the day and have a party or have family gatherings. These are large amounts of sand, over a meter above the shore, or above the ocean surface. And these happen on their own. And so we started to then question, well, what if we could tap into that? Like, why does that happen? And the hypothesis was that it's the relationship between the geometry underwater and the force of the ocean, the currents, waves, and tides. But if you could change that geometry by placing objects, like submersible geometries, you could then promote accumulation rather than erosion. So in our lab, we set up these tanks, we flow water, waves, and currents, we place different geometries, and we then study what kind of accumulation results from those geometries in order to maximize the sand accumulation or deposition. We also study it like a satellite view, so this is almost as if you were a satellite looking down at how the different seasons or flow of currents changes the accumulation of sand. And so the proposal is that we can submerge these objects with the specific geometries that we see in the lab, and we can test those at 1-to-1 scale in the Maldives. And so we've done this 4 different times. We have a National Geographic grant to do this in the Maldives, and we scale them up 1-to-1, which is roughly 30 to 40 meters in the one direction, 4 meters by 2 meters. And these are the same geometries that we saw in the lab, and we place them and study them through satellite imagery, drone video photography, and physical measurements to try to understand how the geometry then accumulates sand. And so in this one from 2019, we saw about a 1/2 meter in new sand over the course of 4 months. And we chose this flat lagoon because it's like a blank canvas. You know, it's roughly 2 meters in depth, depending on the tide, plus or minus a meter. And we saw a 1/2 meter of new sand in just a very short period of time. And so this is really promising results. What we're aiming to do at the end of next month is go back and look at a phase 2. The first phase is that you accumulate sand. The second phase is that you seed it with vegetation, and that then builds roots and hopefully has a positive feedback loop where more and more sand accumulates and you can create a more permanent island. So all of this work is trying to challenge this question of smart, whatever, smart construction, smart products, smart fabrication. And typically we get into this paradigm where the smarter the thing is, the more devices it has, the more complexity it has, the more energy it needs, or maybe the more failure it has. And so look at the Nest thermostat, look at Nike's self-lacing shoes that have batteries in the soles. Like, there's lots of examples of the smart thing that costs more money, fails more often, takes more energy. And so then you're up against this thing, well, is that really smart, or is the dumb thing smarter? And so we're always thinking about that for ourselves. How do we make things that are smart, where smart means less, smart means more elegant, smart means more simple, but more agency and more capabilities? And if we look all the way back to that DARPA grant that I was talking about 10 years ago, roughly, almost every one of the researchers under that grant switched from electromechanical robotic systems towards material systems, whether those are synthetic biology, material science, programmable materials, printing, soft robotics, et cetera. There's really a shift going on right now where smartness conventionally meant robotics or computing in the very narrow dimension, to smartness meaning materials and environments. And there's sort of two perspectives here. One of those is that robots aren't going away. Yes, car factories and many other places are going to be used more and more automation in the classical sense. And if that's the case, we need to link up the opportunities that are embedded in materials. So we need to not just think of materials as our slaves and robots as the extension of the human mind, but rather it's a collaboration between all of the awesomeness in computing and robotics, as well as all of the awesomeness in our physical environment and material properties, and the creative collaborative potential of humans. And those are really the 3 dimensions that we need to think about. But the other more ambitious one is that materials are the future of robotics and computing. If you look at DNA origami, or you look at DNA computing or quantum computing, there's a lot of interesting dimensions at the small scale or even larger scales like I'm talking about, where we can embed sensing, actuation, and logic in our physical environment. And that becomes the forefront of robotics and computing and what we call smart. So the vision of the lab is that today we build smart robots and machines, and tomorrow we'll build smarter materials and environments. Thanks so much.
The first panel this afternoon, I'd like to introduce the moderator who will introduce the speakers and the topic. So I'm delighted to introduce Ingrid Vasiliu-Feltes. She is CEO of SoftThread, an information technology company. She also serves as the Chief of Clinical Compliance and Quality Assurance at the Department of Psychiatry and Behavioral Sciences, and as Director of the Clinical Research Trial Program. She is a deep tech, Web 3.0, and precision health executive. She is recognized as an innovator, strategist, ethicist, globalist, futurist, TV media consultant, and author.
I'd like to introduce our speakers first, and our panel will focus on the pre- and post-pandemic trends we see in smart city deployments. So I hope you'll enjoy the topics that we have. This has been a major trend over the last few years, but now we feel we've reached a revolution in smart city deployments. So first, please allow me to introduce our guests. I'll start from the right side, Professor Messenger. He's, of course, a well-known professor at the University of Miami. Please allow me to read some of his bio. Professor Messenger is a professor at the University of Miami in the Department of Psychology, Pediatrics, and Electrical and Computer Engineering, as well as the Linda Ray Intervention Center Research Director. He's also the director of several of the Social Systems Informatics program at the Institute of Data Science and Computing. Welcome, and we're excited to hear about some of your expertise and experience in smart city deployments today. Then I would also like to introduce Umar. He's the Managing Technical Director at Microsoft, leading a team focused on the Internet of Things. His team works with partners and customers to build innovative solutions on Microsoft Cloud. Umar has worked with software development for 18 years, has been with Microsoft for 10 years, and is also a startup owner. Outside work, Umar is a lifelong learner and martial artist. Thank you for joining us. Then we also have Lercio Albuquerque, Vice President of Cisco Latam. Lercio leads the strategy to foster innovation and digitalization across the region. He's supported by his local team at the Cisco Partner Ecosystem and delivers positive outcomes for customers, government, and society, helping to solve problems, improve productivity, and empower a more inclusive world through the employment of technology. Welcome. So first, I wanted us to take a moment and reflect on the recent 2 years that we've noticed in deployments of smart city and what has changed in the post-pandemic environment compared to what we experienced before the pandemic. Additionally, I hope that we can comment a little bit on some of the geopolitical situation that we've experienced over the last months and how that maybe has the potential to also change the way we deploy smart cities globally. First, let's start with one topic that has been on all our minds. As we know, many international organizations have highlighted the fact that by 2030, we expect 2/3 of the world population to live in urban ecosystems. And that involves changing the way we live, the way we work, the way we educate ourselves and future generations. So I would like us to touch a little bit on how has the pre- and post-pandemic economy influenced smart city deployments. So let's start with maybe Professor Kelly. We'll direct that one first to you.
See if this is on. It's on. Okay, good. Yes, hi everyone. You know, the biggest impact of the pandemic has been, of course, the remote work phenomena, and which has had tremendous implications for the real estate markets especially, but for the economy in general. It's reoriented where everybody lives, where companies are locating. One study that just came out said that half of the increase in real estate prices that you see in places like Miami is due to remote work. And in fact, a city that is 1% more in terms of how much remote work they do than average has almost 1% higher increase recently in their real estate prices. So this has really affected how people locate in cities and therefore the real estate and construction economies. But beyond that, there's the impact on productivity. So whenever you switch to remote work, you're saving time on driving, you're reducing traffic, which is saving time on other people driving, and this extra time allows people to be more productive, to get more done during the day. In the end, what drives the economy forward, what drives economic growth is productivity advances. And so you see tremendous increases in productivity by things like remote work, things like smart traffic setups that increase the amount of time people have to get things done. Other technologies like 5G have had big impacts on the economy as well, although the impact on productivity still remains to be seen. If we're using it to download movies, I'm not sure if we're getting more work done with it, but I think that it's one of those technologies that over time people will figure out ways to use it to increase how productive they are.
Thank you. Would you like to add anything to your observations in smart city deployment?
Absolutely, thank you. Is this working?
Yes,
I think
yes.
so. First, thank you so much for having me. I would say that the pandemic has been the biggest accelerator of the digital transformation, which basically started in 2015. So if you think about the technologies that are driving the fourth industrial revolution, which basically is big data, cloud, IoT, and AI, with the pandemic, this has forced organizations in the private and public sector to adopt these technologies. So I would say this is the first change we have seen, is the acceleration of adoption of these 4 key technologies. But I would say as a consequence of this, security has become a key concern for any leader. For example, if we look at the Colonial Pipelines ransomware attack last year, where it actually affected gas prices in the United States, this was something that we didn't affect. So in the past, when we thought about building secure solutions, we only thought about securing information technology, IT. But with the new world, everything being connected, we got to think how we're going to secure OT technologies, so operational technologies. So these are the changes we are seeing in the technology front. And I think the positive side, again, is that the pandemic has accelerated the adoption of these technologies.
Thank you. What about at Microsoft and at Cisco in general? Have you seen any changes in enterprise adoption?
So first of all, thank you very much. Honored to be here in the name of Cisco. I think the main thing that everyone should have in mind now is regarding people. So the technology that we used to have there 2 years ago, or the one that we have now, of course, that we have had some evolution, but the mindset on how to use them to the quality of the people. So absolutely, it's impossible to have today in this connected world one country that can be considered successful without being a winner in the digital era. And it's impossible to be a winner in the digital without the inclusion of the society. So I think there was, in the past, there was like a lot of discussions or questions about the smart cities are luxury or just for the countries who has money, but it's not. So it's not luxury, it's quality of life. So when we can, with technology, to connect the doctors with the patients, or the students with the teachers, or to connect the opportunities to the millions of people who are on their knees praying for one. So now is the time to use the technology to include the society, to take care of the people, and of course to use the 5G or the IoT, the Internet of Things, or the brilliant presentation that you saw here today. So we are moving to, I don't know, in 10 years, 100 billion devices connected, but they all should be done looking to the people, to the quality of the people, to the improvement of people's lives. So I think this is the difference that I see today. In the pandemic, you're right, helped that a lot. Everyone was learning how to swim, and with the pandemic, everyone was thrown into the ocean and let's swim. So that's what happened.
You're absolutely right, and I think that's why some of the experts globally have called it a smart city revolution, because with a revolution you have good things, but also sometimes bad things. From a psychology and society perspective, Professor Messenger, would you like to share some of your observations about what has changed in the pre-pandemic era versus the post-pandemic era? And do we see anything good or only some negative consequences?
Sure. Again, thanks for having me. So I would say that with revolutions also come counter-revolutions. So we're here at the University of Miami. Many of us teach. We taught digitally, and we were thrown in the water, and we did learn to swim, or at least float. And then we were told, no, you have to go back in the classroom. And so different agents in our smart cities world have different agenda, and huge actors like universities, like healthcare, have to balance the advantages they saw as they learned to swim with their old securities of being at the edge of the pool. And it's interesting to kind of reflect. I was just thinking, oh, well, what do students do in classes when they're forced to come in person? They do what no doubt some of us will do, is they look at their devices. We always think about that and say, oh, that's terrible, that's bad. But in fact, what they're doing is they're connecting to 5G.
Mm-hmm. Great, thank you. A recent report from the World Economic Forum highlighted that a lot of jobs in most industries will be automated, and some industries will record even up to 70% of automation, and a shift towards novel ways of interacting, not only in the workspace, but also in the education space. Can you comment a little bit on how you see the converging technologies play a role in this new era and some of the potential pitfalls?
Well, so I study in my daily life, not my moonlighting life. I study kids moving around classrooms, little kids, preschoolers, some older children as well. So preschoolers, you guys may or may not know, were like 2 and 3-year-olds, let's say 3 and 4-year-olds, were in front of Zoom screens. This was basically an experiment that did not work, right? What they wanted to do was be off there. There are digital devices, of course, which are designed, corporate inspired, which are designed to capture their attention. A Zoom view of your preschool classroom in which the teacher is trying to, play games did not work. And I think we should remember that development is inherently conservative. So I think development is important because, in fact, the society is constantly reproducing itself as kids grow up and become adults and so on, as we become older and et cetera. But development is conservative, right? So we grow up as we are reproduced as cells in an aquatic environment, but we haven't lived in an aquatic environment for tens of millions of years. Likewise, kids' experiences in school, I believe, but whether or not I believe, I think that the society believes, needs a big physical, actually there, physical interaction component. It strikes me, I guess, from the perspective of this forum, that our current digital revolution is not there yet. So there might eventually be a digital revolution in which, my preschooler goes to a virtual preschool and bumps into kids and they step on his toe and he has to learn how to say, you stepped on my toe, say, excuse me. But we're not any place near that. So there are these inherently conservative forces at the same time as maybe industry is pushing us forward.
Thank you. And like Lercio mentioned earlier, the impact on people and making sure that the way we deploy smart cities really takes the whole ecosystem into consideration is very important. Another aspect I wanted us to touch on is the fact that when we build these smart cities, we want them to be inclusive, have diversity, of course, but also affordable. So I was wondering, Professor Kelly, if you can touch a little bit on this dicey topic where we want financial inclusion, we want digital inclusion, but how do we make it affordable?
Yeah, no, that's a great question. One of the issues is what can happen in a smart city. You build this great city, this amazing city, and then what happens? Everybody wants to move there. And then what happens when everybody moves there? You see the real estate prices skyrocket, and then it turns out that the people who really benefit are the people who own the property, generally the wealthy people who can afford to live in the new city and so on. So, it's not enough to really build a great city, to build a great, technologically great city. You have to, in essence, combine that with affordable housing policies, things like tax credits and subsidies for building affordable housing. Otherwise you're going to get what has happened in San Francisco and is happening right now in Miami, is that, you make the cities super attractive and a great quality of life, and then, what is the result of that? Everyone moves there, and then it becomes too expensive for, the people who have lived there for generations to stay.
I can think of one city where that happened recently, like Miami. So definitely. Great. So another topic that I thought would be meaningful to touch on is what are some of the major challenges we encounter when we deploy smart cities? And maybe we can talk, you already alluded to one, which is cybersecurity. So one of the trends that we've seen is move towards cyber resilience as opposed to just cyber security. Can you comment a little bit on what you have noticed and if enterprises are really ready to be cyber resilient, or are they still challenged with that?
I think we are on a journey. That journey has just started, but we have made progress. I would say the biggest change we have seen the last 3 years is the adoption of cloud computing as a way to accelerate projects and accelerate developments. So if you think about, if you want to build a smart city that is more efficient, that city has to be more connected. And think about each sensor on this room. If you connect each sensor on this room to the cloud, to a remote repository, the large amount of data that you're going to generate. And data is just data. You got to be able to reason, manage that data, to transform that data into useful information that leaders can take insights and take action. So I would say the combination of building a more robust security posture, and we have heard this term about zero trust security, which is basically an organization focusing on defining the least privilege that employees need to ensure that systems are secure. And it's also about ensuring that the system, you always verify, you always assume that you have had a breach. So when you combine a zero trust security architecture with the cloud, you can really build solutions that are more efficient and are more resilient. So this is the change we have seen in the enterprise and also in the public sector, is the combination of cloud computing and cybersecurity to ensure that solutions are really efficient and drive benefits to the citizens.
Thank you.
Can I jump in?
Please.
I just want to add, to me, the biggest obstacle right now is the regulatory environment. Regulators are very risk averse, and if they approve a technology and it causes some accident, they take the blame. But if they disapprove a technology, no one sees what might have been. And you see examples of this all the time. The 5G rollout was nearly held up by the FAA because they were afraid it would interfere with the plane's navigation systems, which there really wasn't any evidence for that. The Wall Street Journal had a big article on a company wanting to build an electric helicopter port network around several cities, and they can't get regulatory approval for that. They're afraid of safety issues. Even Tesla's, they call it autopilot, and then the regulators, they don't like that, right? So they're afraid that somebody will think it actually is an autopilot, and they can, not do anything, and the car will drive itself. So right now, there's a risk-averse culture among regulators, and I think it kind of gets at a little bit what you're saying. And that's really kind of delaying some adoptions of some great new technologies that are on the horizon.
Absolutely. I'm glad you mentioned regulatory challenges because I think we all are frustrated with those. I was wondering if you guys want to comment also.
No, actually, I was exactly about to talk this point that we could see from the 50 countries that we have in Latin America, many of them have improved a lot in the regulatory. But also, so the pandemic, all the sadness side and the terrible side that we have in the pandemic, the regulatory has also been accelerated a lot. So while we, in many countries in Latin America, we were discussing, how can we allow the doctor to attend the patient? What's exactly the law? How can we do that? Or, oh no, a teacher and a student, how? A lot of how, and never answered. With the pandemic, let's stop thinking about the how and let's allow them. And so at least we had a lot of accelerations on that side as well. And one of also obstacles that I see, not as an obstacle, but we need to find a way to get there. One thing is the cybersecurity, just like our friend from Microsoft mentioned, which 100 billion devices connected are 100 billion open doors for attacks. But also the data that has been acquired. So all these data so one thing is the cybersecurity, another one is the privacy. So how not to touch and to interfere in the privacy, because privacy is a human right, but also to allow this data to be used for companies, for startups, to the ecosystem to create, to evolve. And so a smart city is a smart society. So the society must be included in the opportunities for development and creations of new companies and of new business models must happen with the data that has been acquired without of course, breaking the privacy and the cybersecurity as well.
Absolutely. Digital ethics and digital identity, digital privacy, data ownership, all these challenges now have accelerated as well with the pace of the novel technologies. Everybody has stated that the pandemic has been the biggest and most effective chief innovation and chief transformation officer, but I always like to joke that we were hoping to also have a chief global ethics officer that would take care of all the problems that came with it. But would you like to add anything on the digital ethics portion?
Well, the digital ethics and how it intersects with concerns about privacy. So again, it kind of, yes, the pandemic pushed us forward, but yes, we still operate within a regulatory and also legal framework, which is kind of perhaps rooted in the past. So for example, in the state of Florida, it is illegal to do an audio recording of somebody without their consent. So for example, if anybody is audio recording this session and has not consented, every individual, it's illegal. So in our daily lives, this is not a big deal, but if we form startups or if we conduct research studies, you know, we are part of entities that have legal departments, and those legal departments are like, well, there's no way. How can you possibly understand, for example, we're interested in children's language development. How well children talk and communicate, that predicts their lifetime earnings. Okay, well, how can we influence that? Well, how much they're talked to, their language environment growing up, that's crucial. Okay, let's measure at large scale. Let's put recordings in kids' homes. We know how to do that. We have algorithms for extracting speech for that. Oh, well, wait, you can't do that, you know. So we're still struggling, I guess, with that. On the one hand, the pandemic and new realities pushing us forward, and on the other hand, concerns, and there are also, of course, legitimate concerns about privacy, which are holding us back.
Great.
I can just add on the privacy dimension of this. You know, one of the things you do as an economist, you like watch what people buy and use that to figure out how much they care about things. And you know, there are, you know, apps and other devices that you can buy that cost a little bit more but promise not to sell your data. You know, or you often have free apps that, you know, there's an implicit thing where they're going to sell your data, right? And what you see is people are not really willing to pay that much for their data not to be sold. So, you know, it is a concern in this from an ethical point of view, as you want to let people know if you're in fact selling their data, but I don't sense a huge concern about that particular aspect among people from their buying patterns.
Maybe it's also that we didn't do such a good job globally to educate people, right? Digital literacy, digital fluency, and then ethics literacy and ethics fluency, I think, are still lagging behind the advancements in technology. Actually, I read a few studies that showed up to 75 times per day we consent on our devices. And when you ask most people, they never read any of the privacy and policy regulatory stuff, right? Everybody just goes through accept, and that's it. So I think we can do a better job, all of us as a society, to improve that understanding.
I'd like to add
Please,
one point.
please.
Especially for solution builders, I think where we are right now, AI, artificial intelligence, which is basically machine learning, used to mimic human behavior. The way you implement any AI solution is using historical data to predict a future outcome. But if you look the way that the machine learning models we have today, like deep neural network, it's basically a black box that you throw some information there and you get some outcome. The importance of this is if you're gonna use AI, you gotta build systems that use responsible AI. You gotta be able to understand the impact of the recommendations that you're providing. And to give you an example, it became very popular here in the US, I think 3 years ago, that the US criminal system was using an AI system, leveraging historical data to predict the probability that someone could go to jail in the future. And what happens is that the development team, the folks that were working on that project, did not consider all the different aspects of the solution and the different parts of the population. And what ended up happening is that the solution was biased against people of color. So that's why it's important to understand the impact of your AI solution, understand what type of recommendation you are providing, and most importantly, if you want to build AI solutions that represent the world, you're going to make sure that the development team is inclusive of the world. So your team has to be inclusive. So you got to have representation from the different segments of the population that are going to be affected by that solution. So I would say a responsible AI ethics is one of the key priorities for Google, Microsoft, and the main technology companies who are driving the adoption of AI.
I'm so glad you mentioned that, because usually we have to convince people in the technology world to talk about that. So building a culture of digital ethics is very important, and having the responsible and trustworthy AI component equally important. Maybe we can touch a little bit, we've talked about the challenges, maybe we talk about opportunities and the trend that we've seen in building ecosystems, and converging technologies are more and more deployed as opposed to a single technology. Maybe, Lurcio, can you comment a little bit on what you've seen in terms of converging technologies, and if you've had a shift in how enterprises adopt these converging technologies, or if you see the same trends as prior to that?
No, I see that happening, and the opportunities are simply huge for the public sector and the enterprise sector as well, because the technology that has been used are absolutely the same. So we talk a lot about, for example, the 5G, but we said 5G seems like it's everything, so we don't need anything else other than 5G. But actually, when you put the conversion with the Wi-Fi 6, let's say, so Wi-Fi keeps being one of the technologies that will be the most used because it's inside. So if you have, for a smart city, an ambulance that is totally connected, the bed, all the equipment's all connected through 5G, when this ambulance gets into the hospital, there inside the hospital is totally Wi-Fi 6. So this converge of the technologies, it can be used for new opportunities. Also, when more and new technologies, like it was mentioned here, can be connected, so the 100 billion devices being connected in the next 10 years or more, that's the data that we have, it's more opportunities. So more growth, the connectivity of the enterprise sector, of the private, of the public sector, of the society, the creation of the applications. So application is driving the world. So all the data that has been connected doesn't mean anything if it's not to be used by something that is good, so something that can generate the result. So all the creation of the applications that will drive the present and the future world is also an amazing opportunity. So the opportunities not only for the business, for the enterprise companies, also to the government, and also to the government, digital government, to improve the services to the society and to the human being, it's simply amazing. So of course that what we have now and we see ahead, the ocean of opportunities simply growing and growing more.
Thank you. We have only a few more minutes. We're coming to a close of this panel, but I thought it would be nice if we finish with what future trends you see in this post-pandemic era, and do you think Web 3.0 will be playing an important role in smart city deployments, or is it just a hype that's going to take some development? And then also maybe which industry do you think is going to play the biggest key factor in driving smart city deployments? Professor Kelly, you want to take this first?
I was actually I'll just use my time as I was going to chime in on the last thing. The biggest area of convergence that I see is in terms of sustainability. So you have companies like the ones represented here trying to be more sustainable. You have individuals as well, but you also have cities that are trying to be more sustainable. So they're doing smart metering, they're rerouting traffic, they're installing energy efficient appliances that are smart. All these things, charging stations, electric buses, all these technologies are designed to make the city more sustainable. And it's having good results in terms of making the city not only more energy efficient, emitting less pollution, but also lowering their costs as well. Using less energy, less electricity, less fuel lowers their costs. So it's been a win-win, and it's been, I think, an area where everybody is moving forward without a lot of obstacles.
Thank you. Professor Messenger, you want to go next?
I don't have a guess about which industry. I mean, I've talked a little bit about educational industries and how they may be not in the lead. I was thinking, though, about ethics and Web3, and I was thinking about the research you were talking about, and the kind of implicit assumption that when we're on our devices, when there's a screen in front of us, we're entering this other world. And yeah, we're willing to let our data be used. And to what extent we think that there's a real divide from the real life world, from a physical world that's less digitally mediated, right? Because it could still be digitally mediated. I might be wearing glasses that are filming you, that are filming me, etc. And the degree to which we, I think, consider that public behavior in the real world, public behavior kind of in the United States ethical framework is considered fair game. So where you walk around is considered fair game. But hold it, what if I, record every moment of your house's life and when you leave, and put that on the web? We would say that was stalking. So I think we're still trying to understand what kind of digital world and what kind of smart city we really want to live in.
Okay. You want to go next?
Sure. I would say if you want to build, like I said, a city that is smarter, is more efficient, you got to make sure that that city is connected. And if you think a city like Miami, how many applications, how many software as a service solutions a city like Miami, administrators, leaders in the city of Miami need in order to make decisions? And the challenge we see is that there is not a common language that each of those applications can talk. So we got to build a way, what we call a common data platform, where all these platforms, all the different applications, they can talk the same language. So if I'm a city leader, I want to make a decision, I can get data from the different solutions that are available. And at the same time, as city leaders start to adopt more and more software as a service solutions, they got to be confident that those solutions are secure. If I give you an example, the Park mobile app, they had a data breach last year. That affected probably all of us here because we had our data there. So not only we need to make sure that these solutions talk with each other, they use the same language, but again, we got to make sure that they are secure.
Thank you. Last.
I think as a final words, just like to leave a thought as, of course, that all the industries will be touched. So we're talking about healthcare, transportation, talking about absolutely all the industries. Of course, that everything with technology can be automatized, everything. So AI will automatize everything. And actually, for many of the things that AI does for us, we want them so to think for us, to decide maybe the ice cream that I prefer, or which is the place in the world that I want to travel. But there is one thing that must not be forgotten, is that what will never be automatized is a hug of a human being. So never. So we can never forget about the mental health and the use of the technology as a tool in our hands, not we human beings, a tool in the hands of the technology. So we must never forget that in the end we are human beings, and everything that the technology must be used is for our wellness and not the opposite. So let's use technology as a tool, not allow technology to use us as a tool, just like we see in all of the societies today.
Absolutely. What a wonderful final comment. And so just to recap, we touched a little bit on pre-pandemic trends, post-pandemic trends, some of the technology trends that you've observed, but also challenges that we encounter. And we would like to end this panel on emphasizing what all of you have mentioned, that we want to deploy smart cities for improving quality of life for humans and for future generations. So thank you so much to all of you. It was, yeah. Oh, absolutely, that would be great. Do we have any questions from the audience? Yes, please. Can you talk a little louder? 'Cause- Yeah.
Imagine a machine gonna get cognitive intelligence and they can do a lot of stuff in future. So how are we gonna control that?
Do you want to start or you want to take it?
I would say that is a tough question. It's very complex. I think there are a lot of smart people in MIT, Harvard, thinking about how we are going to tackle that problem. But I would say the first thing, I think where we are with technology today, especially machine learning, deep learning, we got to understand what we are inputting into the box and how we are getting that output. So there is a lot of research on what we call explainable AI, which is how you understand how your machine learning model came to a certain decision. So I would say this is where technology companies are very focused right now. And of course, you got to make sure that the way that these organizations are using their data adheres to all the privacy requirements. So if you think about the GDPR, also the California data protection law, our organizations, our software organizations, got to adhere to that technology. So I would say it's a mix of having good privacy laws and making sure that on the technology front, people who are leveraging machine learning models, they understand how they work.
Thank you. You want to comment? Or? Well, I can just share that European Union just published a digital ethics act also, so a lot of good data is there, and also the Transatlantic Act that helps with some of these questions to have responsible and trustworthy AI. But just a tiny nugget, data hygiene, data stewardship is very important, and having a robust data governance program is essential in some of the things you mentioned. So working together in an interdisciplinary and cross-disciplinary way with ethics experts, subject matter experts in technology, regulatory compliance helps. And that's the only way to have an immersive cross-disciplinary approach to it. Otherwise, it's not going to work. Great. Any other questions? I see some, yeah.
Yes, being a believer in all of these smart city technologies and everything, I worry about, the divisive nature of what we're talking about. I'm a physicist, but I see that, you're speaking that 2/3 of the population are going to live in cities. I also see that, the interdependence between cities and the countryside has been eroded almost to nothing. And I see the results of that. For example, it's the Midwest, we have all these unemployed people that get radicalized because they don't see a future. And it seems like smart cities might be just half of the name, and smart cities and not so smart countryside. Mm-hmm. And so are we going to need a force field around the cities to keep the countryside people from coming after us because we have taken away their livelihood?
You're totally right. Actually, there's a conference in Davos going on, and they're expressing similar concerns as you in terms of the long-term sustainability plans and the dangers. Also, several reports about the future of work have highlighted the same concerns as you mentioned, that we must have an effort to reconfigure the work environment, because yes, a lot of jobs will disappear. In certain industries, actually up to 47% of jobs are completely supposed to be shifted over the next 2 to 3 years. But the good news is that there are new jobs appearing that are more dynamically adapted to these smart city environments, and that there are some companies who care a lot about sustainability and are working towards reconfiguring, reshaping their infrastructure. It's a work in progress, though, and I totally agree, absolutely.
If I could just chime in. Yeah, so, one of the things, and I think you're hinting at this, that we saw when manufacturing left, overseas was the new jobs were created, but, the people who lost the manufacturing jobs were not trained for those new jobs, and so we kind of like blew it on that. And what we have to avoid is doing that again, right? So, it is true that there's going to be a lot of jobs that are lost due to this, the smart revolution. However, there's also going to be a lot of jobs created, and so the challenge is to retrain people, to invest in education, especially education for those who are older, to get them trained for the new jobs, which are actually more productive and often higher paying. So, this involves a lot of work on the education system. I think, we commented earlier that, or there was a comment earlier that, the education system's a little bit behind here. So, a lot of companies as part of their sustainability program are investing in the education system, but there's a lot of work still to be done to retrain people for these new jobs to prevent the kind of issues that you're talking about.
And also in terms of industries, to your point with food, developing new ways of producing food is a top item on the agenda, and a lot of publications are highlighting not only.
Our solutions tend to make us more vulnerable, like this whole supply chain joke. It's supply chain. Now, supply chain means we send out a job to China and Asia, and now, our ability to rapidly change is totally hampered because we have created a single point failure system.
Well, I think there were more issues with the supply chain. Go ahead.
Yeah, no, I mean, your point is well taken, but there's a trade-off, right? So, one of the things you want to do to make things low cost so that everybody can afford it is do it at scale. Doing things at scale often requires doing it in one place, single point, just as much production as possible in that one area. That keeps the cost down, but it also has a trade-off, as you're saying. It makes you more vulnerable to supply chain issues. And so, how do we balance this cost scale argument versus a resilience argument? I think, what's been exposed a little bit is that our supply chain is less resilient than we thought. Maybe we need to shift a little bit in that direction. But it's not generally the case that we can just say, hey, we can just spread our production out over multiple countries and expect, the prices that we've come to enjoy to be the same.
Any other questions? Oh, yes, please.
So with a truly smart city, it's kind of the responsibility of the builders to develop their infrastructure and operate and report on sustainable infrastructure. And with that in mind, how do you believe we should go about making sure that information is accurate and truck reliable while not centralizing it and keeping it decentralized so there isn't many people feeding into it?
Well, as the Chief Innovation Officer of the Government Blockchain Association, I'm very tempted to say that something in that solution, maybe for smart cities, could also incorporate at one point a decentralized solution, such as blockchain or other ledger technologies. I don't know if my colleagues want to add anything to that, maybe real quick, or if not, also, as you know, Web 3.0 is maybe one solution, but still, it has other negative potential consequences. So.
The reason why I'm asking is because there's also the idea of having multiple players being able to bring in information. Yes. The thing is, there can be certain things between even county and agencies, in for information that contradicts each other.
Absolutely.
Whether on placement certain things or data being fed. So how do we if we have obviously a centralized place, then we can make sure consistency is present, but with all of the decentralized.
That's a great question. It's highly complex, though, so I would encourage you, let's touch base. We're all available offline, maybe follow up, and thank you so much for that opportunity. The World Economic Forum has actually a very good publication that addresses global data governance, so that's maybe one resource we can also look at. Thank you. Thank you so much for the opportunity.
Finally.
That's what I would have. It's kind of a historical thing.
Intense because it extended reality. UI also part of the experience of the project. So I would like to introduce the moderators of this panel. The panel is titled From Zoom to Extended Reality. So Nick Sinoremas is the Vice President for Research, Computing and Data, and the founding director of the Institute for Data Science and Computing, IDIS. He holds faculty appointments in the School of Medicine and the College of Arts and Sciences. Before joining UM, he held leadership positions at the Scripps Research Institute in Florida, at Rosetta, Merck, and Double Twist. Thank you.
Thank you, Rudy. Is it on? It's on? Can you hear me? Okay. Great. So thank you all for coming here today, and thank you, Rudy, for the introduction. So we have another great panel here to follow up a little bit the discussion that we had in the first panel about how the smart cities and what is the pandemic and so forth. But here we wanted also to discuss a little bit more about more specific and disruptive technologies as they are coming to us. And here we have this panel that we call it From Zoom to the Extended Reality. Right? And Zoom, we can call it as a teleconference aspect, how we all moved to actually going from our phone to having a video conference and a teleconference. And now we're going to do new different technologies, extended realities, virtual reality, mixed reality, all of these very interesting terms. So we have a great panel here today to help us figure out this kind of transition, and also understanding how these new technologies can influence the way that we live, aka smart cities, smart environments, smart living, whatever we want to call it, and so forth. However, I would say is that there is and in the midst of all of this, we had the renaming of Facebook to Meta, from Metaverse. We have a new Doctor Strange movie, the multiverse, right? So all of these things are happening all around us. It's happening everywhere. So we have a great panel, as I mentioned earlier, today to help us, first of all, understand what these new technologies are, how we can interact with them, and how we move forward. And I will start introducing very briefly the panel, so I'm not going to give a whole bio for everyone. I will start actually with Ruth Ron, who is sitting on the other side, so I'm trying to mix things up. So Ruth is a faculty at the School of Architecture, and her work involves the interface of architecture and technology. In the middle, here, we have Denise Mendes. She's a software engineer at Microsoft, and she's also part of the group of the mixed reality at Microsoft. And last but not least, we have Kim Griffender, who is the chair of the interactive media at the School of Communications here at the University of Miami. And he's also the program director of creative computing at the Institute of Data Science and Computing. And with that, I would like actually, the first thing that I would like our panelists to address is give us a little bit your definition of what you think about this extended reality and virtual reality world is, right? So we all have different ways of how to view that. Facebook has got its own. Unfortunately, we don't have anyone from Facebook to give us their opinion. But I would like, let me start actually with Denise first. And to give us a little bit, to tell us a little bit about how would you define this new space and how that manifested in the work that you are doing.
So I work in mixed reality, and mixed reality is a merger of the physical world and the digital world. And it manifests itself in the ability for devices to scan and understand the world around you and know the surfaces of your environment and allow digital content to interact with those surfaces. So in this case, a digital hologram would understand the volume of the space, and it could actually scale to be the size of this room. Or if I was in my living room, which is way smaller than this, it would scale to be the size of that room because the world, this digital world, starts to blend into your physical world. And in particular, you wanted to know more about like how it applies to my day-to-day. So I work in the environmental understanding and data science team. So my team's job is to actually build the algorithms that do the computer vision to understand the mechanics of the world around you, create the surface reconstruction of the world, and allow holograms to stick in space. And not just stick in space. If I put my hologram here in the middle of the room and I walk around, I walk outside and I come back, my hologram persists over time. So that is the kind of group that I work on, and specifically I do the data science bit, how do I measure the stickiness of a hologram or the persistence of that hologram and the accuracy and stability of that hologram through data, telemetry, and ground truth.
Great, thank you. And I'm going to ask Kim actually now to help us define this.
So how do we define the metaverse? There are a lot of definitions floating around, so I'm going to give you mine. It's really an interconnected, it's an interconnected network of spaces that are persistent, that are going to form their own cultures, that are going to have their own rituals, and they're going to be connected by different means. The metaverse is not only something there's an artificial metaverse, which is what I guess Facebook is trying to do, but also there's a digital twins metaverse, which is a recreation of the physical world in a digital form with information and things like that. The second question is how it affects me. Well, it affects me in the way that I'm teaching in the metaverse now. This semester, we taught our first class here at the University of Miami called Religion and Sacred Spaces in the Era of Virtual Reality and Artificial Intelligence. This course was in collaboration with a professor from the Religious Studies Department and a professor from the School of Architecture. And we met every week with the students. Each student had their own headset, and we met each week with their students in the metaverse. And we started the course with created spaces that already exist, and then eventually as the course moved on and the students grew more familiar with the space that they were learning in, they started creating their own spaces, their own objects, and their own interactions that were traditional for each class, that we started kind of having this ritual before class and after class, and each time we entered a new space, students started to feel more and more comfortable with this space. The course lasted 14 weeks, and it just finished at the end of the semester now. I also run the XR initiative, where which has the Digital Twins Lab, which is part of iDisk, and we develop several virtual and mixed reality apps for researchers across campus.
Great, and Rose?
So from my perspective, augmented and virtual space are actually an extension of architecture, of the space we inhabit and exist every day. And I see architects have been working with the realm of digital three-dimensional space for several decades already. However, this space was separate, and it was built to represent the real world, and it didn't build for social interaction or multi-user. And I see the technology expanding now to start to accommodate these possibilities. And I think for us, for architects who are thinking about designing spaces for human use, for social interaction, for housing, for work, and I think architects and students of architecture have learning this capabilities and thinking about these things, if they are exposed to virtual and augmented reality, they can expand their creation and imagination of what these spaces could be, because I think we are not already there. We are just have some glimpse or idea how it could be in the future. So that's part of what I'm trying to teach and talk to my students.
Thank you, Denise. That's great. And I would like you to pick up from what you just left, Denise, and which is basically if we now have some kind of broad definition of what extended reality is and virtual reality, which is the attempt to bring the physical and digital world together. So let's also bring it up a little bit to the theme of our conference here, which is like the smart cities, the connected cities, the human element of that. And following up a little bit of what Ruth was saying is that I would ask now actually Kim first to tell us where some of these you see these kind of technologies emerging into the convergence with the smart cities. How this kind of physical and digital world coming together can have impact into the cities of the future or to the living of the future.
So there are three spaces. One is we're creating this artificial world online right now, and which has physicality, it has a location, it has space. Our brain sees it no different than a regular space. And I think we can learn a lot from existing cities, not to make the same mistakes as we're going to make in this virtual world that we're creating right now. The second part is I think that every city will eventually, in the next couple of years, have a digital twin of itself. And this will be run by private entities or the government, but people will be able to download the digital twins, and developers are going to be able to see how their building looks like in a city, or kind of do traffic measurements, and all that data will be available for people. And right now it's a little bit all over the place, but eventually my guess is that city governments are going to kind of start collecting all that data into one space, and a digital twin will be born. I know that Orlando is already working on this, but I don't know of other cities right now. And finally, I think where a lot of interesting things are going to happen is between this intersection of the artificial reality and reality. What happens when you have a digital twin of a space and the physical location? What are the interactions between these two spaces?
Great. And Denise, if you can elaborate a little bit more of that and also bring in your experience, as you said, because you have the data science responsibilities in your group, of how do you think that, the technologies that we're talking about and what Kim was describing with the concept of the digital twin, and how, in the age of datafication of everything, right? Data is everything, we produce data on everything, so we have a digital twin that actually we're feeding it. So how would you see the future in that is moving?
Yeah, so I work with the HoloLens, which is all about visualizing your physical and your digital spaces. So the digital twinning and how you can represent the architecture of this building and all the layers in between, and turn those layers on and off while you're still in the room and interact with those layers is a huge part of that. How do you enable that in a way that scales and aligns to the real world? And part of the way that we do that is it's all data, right? How do you visualize this data? And all data is three-dimensional. Any data scientist who's working on data knows that data has multiple dimensions. But we're limited in our facility to express that data or share that information with others. We have PowerPoint slides and two-dimensional whiteboards that we try to express data in that dimensional concept. So data is dimensional, and visualizing that data in its reality and its entity. Even like if you think about, health and anatomy, an MRI is three-dimensional, right? But doctors have to look at it a layer at a time. They can't lay it in front of them and actually move the layers around like they would because of the type of human beings we are. We actually interact physically. So our team really works on how do you interpret that data? How do you visualize that data? How do you interact with that data in its 3 dimensions? And where do you store that data so that it can, go to the cloud and come back? Because it can't, an MRI can't live on a device. It's huge. And that's part of the pieces that we worry about, is more of the interaction of the data and visualization of the real world and those digital twins.
Great, and let me also actually ask the similar kind of question to Ruth, but also bring it into her experience of how you educate new architects, right? That they are looking, and as you mentioned something very, very important in your first comments, is that our world and architecture is always 3-dimensional. We live in a 3-dimensional world. How do you think that technologies like extended reality, and how do you think that that type of things can influence even the educational aspect of what we need to be educating the next generation of architects, but also in general, the next generation?
I think virtual reality bringing a lot of potential to architecture education. For example, being able to share 3D models and being able to occupy 3D models, being able to see them in real scale and in immersive way is relatively new and still limited with the number of devices that we have, and technology limited the number of the sizes of the models and the files. So I think the potential is immense, because students and architects who are working, they are thinking in 3D, but there's a limited way that our imagination, although we imagine it, to experience it in immersive way, one-to-one scale, is amazing. And being able to share it with clients, people in the city, making this data more accessible to the public is another amazing opportunity.
Yeah, I have a follow-up for actually both things. Denise, you were talking about being able to visualize data in 3D and how that's going to change, and that's how we're meant to visualize data. But I also think that once you visualize data in 3D, you're experiencing it. And the same thing goes to Ruth. I had architecture students, and I was working in 2 classes that had architecture students this semester. One was Ruth's class, one was my Sacred Spaces course, and students in architecture had to build spaces and bring them into VR immediately, and they could immediately see their mistakes, and they were thinking about user experience rather than only design. And this is something that, I come from the Department of Interactive Media. We're all about user experience. And when you're starting to move into these virtual spaces, I think we start thinking about experience a lot more, and that's really a good thing, that we start thinking about how people interact with the world around us, how people are going to interact with cities, and things like that.
Great. Thank you, Kim. Okay, so now we will move to the mandatory pandemic question. We are still in the COVID-19 era, post-pandemic and so forth, but we all have a PTSD from COVID, I imagine. So it is customary now to get into this kind of questions and ask basically our panel to comment a little bit of what was the influence of the last couple of years. We all spent more time at home, we all spent more time isolating from each other, intentionally or unintentionally. So how do you think that these kind of technologies have helped, enabled the behavior, good or bad? And I will start with Kim in this time.
Pandemic. Okay, no more Zoom is something that I ask for. I really feel that the pandemic just accelerated things quite a bit. It made us more open to try out, because of our isolation, it just made us more open to try out new technologies that were on the fringes, that were just there, and we just didn't have an option to meet in person. So we said, well, let's try this thing out. And it brought these technologies to the forefront and made us accept them more. And some of them were pretty good.
I'm going to take a contrarian view. Yes, Zoom. I work for Washington State. All of my team is remote. I got hired in the middle of a pandemic. There was no way Microsoft would have hired me 3 years ago and allowed me to live here. So for me, the pandemic has actually been a wonderful boon in that perspective, that I get to play with amazing technology on a daily basis. And the company has realized they've doubled down on that technology as an entity. So we started, there's a program called Mesh. So now they're starting to put into Teams. Some of you may use Teams or Zoom, but essentially those 3D spaces now become a little metaverse. So your meetings become little metaverses that you can actually walk into. And the team is doubling down on these hybrid technologies, right? Where Alex Kipman, who is, I call him my CEO, even though Satya is the CEO, he's the head of mixed reality. He says that we want to be the poster child for collaboration and co-presence and enabling these technologies. And he's letting that happen by allowing most of his team to be remote. Even after the pandemic, even after the offices have opened up, I mean, the office is at 10% capacity at any given point in time. Everybody else has moved out or moved to other places to be closer to their families. Now that has a negative side effect. For me, I have 20 years of engineering experience. I'm a principal engineer, so just put me in a room and I'll go figure it out and get it done. So for me, that's great. It's not so great for somebody who's early in career, somebody who just started. And it's not fair to them because now they don't have access to those senior and principal architect engineers in the office with them. But in a way, we're trying to figure out how do we make this hybrid world work, right? It's not fully digital, but it's not fully in person anymore, but in this hybrid mode. And it's accelerated that in orders of magnitude.
Yeah, I think what Kim said, it did accelerate the acceptance of digital communication and video conferencing, but this is not extended reality. So I wonder if the overexposure that we had to Zoom is actually going to hurt the acceptance or the eagerness of people to try to use mesh and environments like that to work immersively in 3D because there's Zoom fatigue and the loneliness and all other aspects the pandemic brought socially on people, mental health and isolation. And how do we to try to alleviate that with tools like Mesh and extended reality, and how then we convince people that this reality has also advantages and so many benefits, and as any new communication tool, this tool does not replace, once there is no more pandemic in the world, this tool will not replace personal contact, but will enhance remote work and all kinds of situations that are not possible, in face-to-face meetings.
Okay, I think Denise, you have a question.
Yeah, in some cases, so Case Western, they taught anatomy during the pandemic with a HoloLens. And they had students that were learning in person from before, and they have all their historical data. And having taught anatomy in a hybrid way, with the students in their own home, but being able to visualize the cadavers and the human in 3D. The students had a step function in learning and had a step function in retention of knowledge. So that is another way like that the hybrid or these extended realities are going to help as well, or have, yes, Zoom fatigue exists, but if anybody's seen our real estate prices in South Florida, people are still coming over here, even though everyone's going back to work. I don't know what's going on. So I think there's a certain appetite for a hybrid type of work, or at least that being able to work wherever and whenever you want.
So, I'm not against Zoom. I think Zoom saved a lot of us. There is Zoom fatigue. I agree with what Denise is saying. A hybrid solution is really an interesting one. But I, spend a lot of time in VR chat and social VR, and I taught in VR, and space matters. The location that you're in matters. And that's something where I think architects can play a big role, is creating spaces where we meet. The experience of social VR is very different than a Zoom. The experience of teaching in VR is very different than teaching in Zoom. We did both. Teaching in Zoom is looking at flat screens. You have 16 or 20 faces looking back at you. You're looking at your own face. It's weird. When you're in social VR, you have an avatar. People get to choose what they dress, what they look like. You get to choose the space that you're in, and we taught in different spaces. We taught in corporate boardrooms where the conversation was clunky and rigid, and then we taught around a campfire where the conversation was fluid, and there was a lot of discussion to that. And I think while Zoom is a tool, I think adding multiple layers and exploring different layers is really important, and space matters.
Can I ask Kim a question? When you were teaching a class in VR, how was your feeling where you couldn't see people's eyes or expression? You could see their emoji expression or simplified expression or movement. How was it?
So that was kind of weird. You could see their heads moving around and looking at you. When they talked, their mouth opened, but it didn't synchronize. But I do know at the same time that the new headsets have eye tracking. They have downward-facing cameras to read your mouth and lips and things like that. So this is coming, and it's if it's pretty good now, I imagine it's going to be even better really soon.
I think this is a great question actually, and Rose took my question actually to some extent. And the reason the question I would phrase it in a different way, and I will ask again everybody to comment on that. Is that okay? So what is the state of technology, right? And we talked about that we are all kind of visual beings and we work on 3 dimensions. But as human beings, we have other senses too, right? We have smell, we have touch, right? We have taste, okay? So, if we wanted a more complete experience, where do you think that the technologies can get us? And how can more real this kind of reality can become, so we can actually merge it a lot better, the extended reality? And some of that can also talk a little bit about the challenges of the current technologies that we have and how, you think that the future could go. So it's not only the challenge, but also the technology. I will start with, go ahead, Denise.
So it's a little unfair because I get to see where the current state of technology is, and like the holoportation, the ability, so it's not my avatar or a cartoonish version of me, but it is a physical rendering of me, my motion, my face, my body gestures. That is so important in a meeting, and I think to teachers as well. If you can't see where the student is sitting there like this, or if they're like sitting on the edge of the seat paying attention to you, you don't know whether or not your content is getting through. So that edge of technology is there, right? I think on the side of Microsoft is the adoption it's happening at the big higher, at the Fortune 500 layer. You don't see it in the home yet. We're a ways away from making that technology affordable in that state, and that a lot of it has to do with 5G and connectivity and optimizations in hardware, but that technology is there, right? Sight is there, sound is there, spatial audio is huge, right? It's not like you don't want everybody's voice echoing at you. You want it to be, if they're looking at you, you can hear them pointing their direction at you and ignoring the person behind you. So you've got the sight, you got the visual, you got the auditory. Smell-o-vision, Not quite there yet, or the taste aspect, but at least in those dimensions, it's there.
I think it's a curious question because we are used to the abstraction of knowledge for thousands of years through books. You know, I don't lick books, or I don't have it. There is a touch to the paper, but it might not be relevant to the content of the book. So there is this distance between senses and learning for decades. Is it good or not good? That's another question, and there are a lot of research that shows that if I have more experience with my senses, and if my experience is more dramatic and spatial, then it will embed it in my memory better, and maybe my response, my emotion will be activated in a different way. But then again, you know, I was listening to a lot of lectures and events about the potential of VR education, and you know, they took the class to a trip in Rome, in ancient Rome, and you know, all kind of places inside the body and in the blood vessels, and this excitement is going to, you know, it's not going to be maintained forever. We are not in an amusement park, you know, a roller coaster for the whole. Let's say if we're doing an undergraduate or graduate degree, so this amount of expectation is also not realistic. So I think technology is definitely advancing, and I think, for example, spatial sound, is what you mentioned, is much more stronger and effective than in real life, you know, because I can use it to focus, I can constructively use it to create focus or emotions and things like that. So on some central level, VR will be better. Some central level, it may not.
Great. So I think we are getting into, I'm getting the 5 minutes warning. So I would like actually now, so we have a great discussion and we can keep going. But that's not fair for everybody. So we would like actually now to open it up and get a few questions from the audience. If you want to ask a specific question to each one of the panelists or for the whole panel, please by all means. Do we have any questions? Yes, we have one question.
It's related to our previous conversation with smart cities, and I was wondering if you have any thoughts about how to develop a code of conduct for this new immersive environment, because the typical social interaction that we usually have has changed in this immersive environment, right? We can't, like you mentioned, we can't read facial expression, we don't see the body movements as we are accustomed to, and then in terms of also respect, autonomy, for privacy, right? Everybody can bump into you. So can you comment a little bit what you envision? Do we need one? If we do one, how do we start? Go ahead.
Thank you, Edwin. Did everybody hear the question, right? Is how these new immersive aspects, you know, how we brought it together, and how that, you know, affects this kind of technologies, you know, following up the previous panel. Is this for a specific one, or anyone wants to take that? Okay, Denise?
So Microsoft owns a platform called AltSpace, which is like its own little metaverse, and you can host conferences, comedian shows. They hosted Burning Man in there during I think in 2020. And what they created was, because, you know, you could have somebody unwanted or unsavory come up to you in this space. So they instituted features like, here's my personal bubble. You cannot, like, your avatar cannot encroach on my personal bubble space. And you can kind of, like in that Black Mirror episode where you can turn people off so you never see them again, you basically, that person becomes, invisible to you. So you can actually have a set of tools available to you to kind of just, you know, if it's unwanted, you know, you get rid of that and that person, or kick the person out. There is a lot of thought to that and discussion on ethics and accessibility as well, right? Spatial audio works if you got 2 ears and they work normally, but if If you got hearing in not one ear, spatial audio doesn't work for you if someone's talking on this side. So there's deep thought, at least on the tech side, bringing into the discussion of how you create these little these metaverses that respect our physical and our social emotional selves.
I think that's a really good question. I think on the personal level, we have to have social norms that we create. But I also feel that as technology emerges, we need, they're putting more and more biosensors on the headsets. And, the HoloLens needs to scan your room before, and I know they keep that on the headset now, but it needs to scan your room and to have all the information of what the room around you looks like. The new Meta Quest that's coming out will have pass-through VR. All that information, and again, that they say that people, third-party apps don't have access to that, but Meta does, so I'm not really sure how that's going to work. But all this information that they're collecting about your homes is also something that we should consider as a social norm. Like, what can they collect and what shouldn't they be collecting?
We have time for one more question, and we have one more question.
So where can one get educated outside of the corporate 500? I mean, the experience that I have had with, the so-called virtual reality is things like the Oculus, which is a really isolating device that is used to push commercial stuff. It really doesn't have any social value. In fact, it takes my grandchildren and makes them very, very isolated from the rest of the world. So, is there a way that you can help us understand, like, where can we see this different reality that you're speaking? I mean, what you're speaking about sounds very, very, very fascinating, but that's not what those of us that are in the business are experiencing. We're experiencing basically a threat to society with the young people becoming isolated.
Very interesting question. Anyone wants to take that? Okay, please.
So the most accessible technology for somebody in their home is Oculus Quest 2, right? It's $365. But it's a game engine. It's a game machine. It is the only way that companies have figured out to get to mass consumers to put a bunch of games on one of these devices. To see examples, so I like the Oculus Quest 2 because they have a workout program called Supernatural on it, which is really a lot of fun. But that's the closest at-home VR experience that I've gotten. We're moving into that pass-through world. So that idea of VR is really isolating. You can trip over a lot of things and hurt yourself if you're not careful, if you're doing it at home. So that pass-through world where you can still see your environment and still interact with holograms is, I think the Apple headset will probably have something like that. And I know the Future Quest is coming out with it. Accessible to you, or right now in the consumer space, there isn't a lot. There's companies who are manufacturing or using the devices, at least the HoloLens, for training and remote assistance. So here's the car, here's all the parts in the car, here's how you maintain it or put it together. Or somebody holoport or comes into your headset and sees what you see to help you figure out what's wrong in the area. And they're using it in medical industry for surgery. I think there was a HoloLens that they brought in 7 specialists or a whole bunch of specialists to separate 2 conjoined twins a couple of months ago. So you're seeing it in that for that commercial space where it has improvements. To get to the point where you see more things for your home is a chicken and the egg scenario. I was talking to Kim about it earlier, is you don't have enough content for these devices at home. And you don't have meaningful content or productivity content for your devices at home. But then you need a whole bunch of developers to develop for the devices at home, but it's not financially great for them to develop for what, 1,000, a couple of devices that are in the industry. There's a whole bunch of investment that needs to happen to get the content to fit the consumer space.
Thank you.
Thank you. Thank you.
Thank you.
We have no break.
Okay, disrupting the building industry. I'm going to introduce the moderator, Max Jaros, Director of Fabrication and lecturer at the University of Miami School of Architecture. He teaches courses on robotics, digital fabrication techniques, and emerging technology in the building.
Thanks, Rudy. Our panel is on disrupting the building industry with a particular focus on automation and fabrication. And we have 3 panelists with us here today. We unfortunately had 2 last-minute panelists, Olivia Ramos, the founder and CEO of Deep Blocks, and George Franco, the founder of Trivatech and Director of Technology at Moss Associates, who are unable to join us to a potential exposure to COVID-19. However, we do have Greg Coleman, who is a lead engineer at C.W. Keller and Associates Incorporated. C.W. Keller and Associates is an engineering and fabrication firm specializing in custom woodwork, taking on projects nationwide from decorative wood interiors to custom concrete forms. They are a collaborative team of designers, engineers, and craftsmen. Trained as a mechanical engineer and graduating from the University of Colorado, Greg is interested in automation and analysis techniques which require to make complex projects a reality. As architectural software and designs continue to progress, he has been working with custom fabrication teams to continuously develop tools and workflows for delivering extraordinary projects cost-effectively. We also have Matt Trimble, who is the Director of Product Development at Branch Technology. Branch Technology is a building-scale 3D printing company that is revolutionizing sculptural architectural envelope systems with its patented cellular fabrication process called CFAB. Branch Technology has won numerous awards, including being named Inc. magazine as one of the 10 most disruptive technologies of 2015. Branch was also a winner of NASA's Phase 2 Level 1 and Phase 2 Level 3 3D Printed Habitat Challenge in 2017 with Foster and Partners. Won an AIA Tennessee Award of Merit for the Design Miami Pavilions located here in the Design District with Shop Architects, and a National Science Foundation Phase 2 grant. Matt was previously the founder and principal of RadLab, not to be confused with the Dean's RadLab in Toronto and Miami, an experimental design and fabrication firm based in Boston, which ran from 2008 to 2018. He's previously taught at a plethora of universities, including but not limited to the Rhode Island School of Design, the Boston Architectural College, MIT, and the American University at Sharjah School of Architecture and Design as an assistant professor of architecture. His teaching has also included private and professional workshops in computational design and digital fabrication for organizations that include Saucony, New Balance, Timberland, and Schneider Electric, and has received a range of grant and awards for design research in robotics, computational design, and experimental construction. His work has been published widely, including in Architectural Record, Architect Magazine, Perspecta, and Metropolis, while also being exhibited nationally and internationally at such venues as the Cooper Hewitt National Design Museum in New York City, the Octagon Museum in Washington, D.C., the Canadian Centre for Architecture in Montreal, Quebec, Canada, and the Hong Kong Shenzhen Biennial Architecture Exposition in Hong Kong. His work has received and contributed to some of the highest honors in the AAC industry, including an Architectizer A+ Award for the One Main Project and the Chicago Athenaeum American Architecture Award for the John W. Ulver Design Building at the University of Massachusetts Amherst. Recent work has included a co-authored paper on the subject of systematizing mass-customized building skins for the Facade Tectonics Institute World Congress 2022 and the Green Line Extension Project for Union Square Station in Somerville, both with Matt Culver. Louiselle Zayas, our final panelist, is the founder of Formateria. Formateria is a design and fabrication studio focused on new forms through a deep understanding of material behaviors and fabrication processes. Through the act of making, they respond to formal, structural, and environmental concerns. Their process is fueled by the research and experimentation of geometrically complex forms, encouraging the combination of a hands-on approach with the age of digital manufacturing technologies, including become the first robotics lab on the island of Puerto Rico. They are a team of architects, engineers, and designers with a multidisciplinary view on how to tackle challenges of different scales, ranging from architectural design, public art, furniture, and industrial design. Founded in 2020, San Juan, Puerto Rico, Formateria aims to work locally while maintaining a breadth of projects, clients, and international collaborations in multiple fields. Their mission is to achieve the highest level of craft and design and excellence for every design pursuit. Luisel Zayas San Miguel was born and raised in San Juan, where he received a Bachelor of Environmental Design from the School of Architecture at the University of Puerto Rico in 2012. He holds a Master of Architecture from the Massachusetts Institute of Technology, where he developed robotic formwork systems as part of his thesis research, receiving the Bill Mitchell Fund Award and the Arthur Roach Prize. He has built large-scale installations in multiple cities around the world, including the Venice Biennale, Madrid, Nairobi, Madison, Boston, and Dubai. In 2013, he was awarded a grant by the Wholesome Foundation and appointed the Quora Matter Research Fellowship in 2015, where he investigated robotic manufacturing processes on stone and presented his research at the 2017 Acadia Conference. Luisel has worked in multiple firms, most recently as a project manager at the NAD Lab, director and NDA from 2016 to 2020. In addition to his professional work, he has taught workshops and courses at a variety of institutions, including MIT, RISD, where he taught courses and workshops focused on digital fabrication and construction. I thought maybe potentially more interesting than some of the background biography, you could each talk a little bit about some of the projects you're currently working on and how that relates to the disruption in the building industry.
Thank you for the invitation, Max. So we work in a wide range of materials and scales. One of the recent projects we've been working on is using clay 3D printers to 3D print organic structures, essentially to help replant corals in the coastal areas of Puerto Rico. Recently, after some of the hurricanes that impacted Puerto Rico, especially Irma and Maria, these environments were heavily affected, and we are part of a bigger group of companies that are helping replant some of those corals.
Not so much a current project, but recently completed. We completed the Alliance Theater in Atlanta, Georgia. And on this project, we sort of worked through right on the cusp of what has been discussed previously, this sort of bridge between digital and physical. And in lieu of having such things as a HoloLens where we could visualize it in 3D, we kind of found other solutions and did some work with Faro using their tracer to project just the line work of a 3D model onto our physical products to kind of give us not only a QC, but also give our team of craftsmen the ability to sort of shape wood in real time to the model without a headset.
Good afternoon. Can everybody hear me okay? It's great to be here. Thank you for the invitation, Max. Very nice to see all of you guys and hear about your work. So a project that I'm working on right now is the new U.S. Space and Rocket Center Space Camp facility for NASA. And one of the interesting things about the project is that we've used data from a lunar scan of the moon's surface and translated that into a custom building skin for this new facility. And I can talk a little bit more about that as needed.
Great. So I wanted to start this off. When we talk about automation, in particular in the building industry, a lot of provocative images tend to come to mind. Robots assembling buildings, buildings being 3D printed, or as we heard from Skylar, buildings assembling themselves. However, it seems that a bulk of what automation really entails is information management, whether that be pulling information from the zoning code and integrating it into a more user-friendly interface, or pulling material information from a central model and organizing cut files. Can you talk a little bit about some of the more unglamorous parts of the automation process, perhaps the types of data you are using, programs you use, and how that's helped you facilitate a better outcome?
Yes, I would say one of the less glamorous aspects of automation is done in the computer rather than, people picture a assembly line at Ford rather than crunching data and spitting back analytical solutions rapidly. A way that I use day to day is working with designers on limitations of material, limitations of cost, but creating these tools that we can sort of walk through it one-on-one in a Zoom call and sort of say, hey, your design has these limitations in these areas. Here's a few solutions. Which do you prefer? And traditionally this would go to them. They would come up with a solution. They would send it back. We would then analyze it on our end, let them know what happens. But this is sort of translated into one moment. We can shorten that feedback loop of, say a slider. I recently did a project with custom concrete formwork, and the sad reality of it is everybody wants these beautiful double curved surfaces, but really the only way to force a wooden form to do that is to mill it away, which becomes very expensive, very wasteful. So what we do instead is we rationalize it and we give it ruled surfaces. But that's not what the designers want to see. They want to see what they design come to life. And we were able to sit there and say, if we shift seams here, here, and here, we deviate from your design by a 1/4 inch or a 1/2 inch, and they can really see immediately how that affects cost and the visual outcome of the project.
I would like to add to Greg's comments. One thing that we work in a day-to-day. We're a small shop based in Puerto Rico. In every project that we work with sheet materials, one of the most important things to do is optimize the raw material. So every project that we work on, it goes through the process of going back to the designer and offering, like some adjustments or some tweaks that could be done to the design to essentially bring back the project to the budget or essentially, recover the project. One specific project that we worked recently, we had a ton of pieces that we need to CNC out of 4x8 plywood sheets. And in this particular project, the first suggestion that we did to the architect is the grain orientation in these pieces actually important. You have a significant amount of pieces that are going to be hanging from the ceiling in this particular project. Is the user actually going to realize that the grain orientation, it's all aligning, west to east or vice versa? And the answer was actually, it doesn't really matter. It does matter if it's going to help us bring, realize the project. And just by moving into a non-linear material like MDF or a material that doesn't have a grain, laminate, we were able to reduce 75% of the amount of plywood that we needed to buy for the project. And when you have a project that you're buying 250 sheets of plywood, especially in the current market right now, where a plywood sheet it's triple or quadruple its original cost, it really helps. It really helps the budget of the project. In this particular case, actually saved the project.
So to pick up on one of the things that Greg said, you said something about kind of the need to force wood into these positions for these forms, which requires you then to remill all of these things. Matt, maybe you can talk a little bit about the process that you're using, trying to move more towards a material process that removes some of the waste in that process.
Sure, yeah. So actually, about 10 years ago, I worked on a project with Greg's company, C.W. Keller, on a house for an architect named Stephen Hall that many of you may have heard of. And for this house, which was in Hastings-on-Hudson, which is New York, the exterior concrete was all cast into CNC milled wood forms. And the basic idea was that after the facade was cast, those wood forms were thrown in the garbage because there's not much you can do with them after that. So that was inspirational for me since then and the team that I work with to think through some new ways to imagine how to use additive manufacturing and the information that we have and generate about how materials work and how we can use them to change the methods employed to create facade systems to dramatically decrease the waste. So we are essentially using our 3D printed forms as positive formwork, which is unknown in the building world relative to sculptural facades. So when we 3D print forms, there is no negative that we cast into. We actually apply materials, all of which are fluid applied to that form in order to create a system wherein each portion of the facade can be unique to every other unit. To dive down a few layers deeper than that, in terms of your original question about these unglamorous parts of the process, one of the things that's become progressively more important to us is the issue of structural optimization and even just structural data in order to make this sort of dream possible of making facades in this way. So we've begun to work with structural engineering firms to build essentially packets of data that respond to existing codes around how to make building facades with particular materials, and to do so in a way that an authority holding jurisdiction can say, okay, we understand the wind loads, the deflection limits, the ability of this panel to remain on this building in certain climates and climatic conditions. So the testing part of this has been very, very intense for us. We spend a lot of time with the NFPA and ASTM running tests to take the structural side of what we're trying to do and build information so that we don't have to do what we're doing on the custom side for every project. In other words, we don't have to have a project-focused approach to realizing custom facades. We can have a product-focused approach. And in order to do that, you really have to build this data so that for each individual project where you have a project-specific structural engineer, you don't have to start from ground zero answering questions about how this panel that's never been made in any other location and has a completely unique geometry is going to perform structurally. So that's been a big part of the work that we've been doing recently.
It seems like in all of these answers, it's really kind of pushing towards this notion of a kind of feedback loop, or being able to move information freely back between the contractors, subcontractors, the architects, and designers, preferably early in the process. However, most of the contract structures that we commonly use often pit the architect and designer against the contractor and fabricator. Can you talk a little bit about the more successful types of collaborations you've had along those lines? Or alternatively, can you speak to any projects that highlight some of the redundancies in the contract structures can cause?
I mean, for my particular case, we operate in a very different scale than C.W. Keller and Branch. So, some of our projects don't even have a contract. We have a signed proposal, and the client says, this is what we want. We want you to design it, and we want it to build it. We want you to give us a full solution. Some other of the projects that we work on, we work with collaborators, with architects, designers in other fields. So essentially we are subcontracted by them to perform or fabricate their designs. So in many of these cases, what we get is a signed proposal and a Rhino file. I like to think that the industry is moving in a direction where it's going to be more three-dimensional, automated, in a way that chop drawings, we haven't worked with any chop drawings, and we don't do chop drawings. So essentially, our contract document becomes the Rhino file itself. And this actually has been very successful for us because we communicate in the same language, because we work mainly with architects or industrial designers that use Rhino to model their products. So in that way, from my perspective, I am already not signing contracts or going through the chop drawing process. But I'm sure that's not a reality to other scales.
Yeah, I think once we move into the scales of the C.W. Kellers and Branch, maybe you guys can talk a little bit about how you see it on your side.
What you just described is my ideal scenario. I think the biggest driver of redundancies that you spoke of for us is typically when things are really sort of over-designed or designed for us. And I think that is sort of driven by tradition of shop drawings. There are often times that we will receive a set of drawings where details have been worked out for us that really are not best practice for us. And due to those decisions, it affects every other surrounding trade. And by the time it gets to us, it's too late because, drywallers have gone here and structural steel has been put there, all based on details that were supposed to help us, but inevitably have just drive up our costs. Something the president of our company is I've seen him say multiple times to new clients is, if you have a rival model, please stop. Like, come to us, let us work together on reaching the cost you want and the result you want. I really hope that it is going in that direction. It's difficult on the larger scale. I think we need to be working with BIM processes and getting more trades involved and trained in that environment, because the sooner we can get everybody on the same page of a three-dimensional contract document, the better, in my opinion.
What I've seen over the last several decades is that most projects fit pretty neatly into one of two categories, and I'm curious if you guys agree with this. So one category is mass production. So you get buildings that are the result of architects really putting on their best puzzle maker hat, and they're taking products out of catalogs, paint colors that have been predetermined, assembly methods that have already been outlined for them, and they're piecing these things together to make a building. And then the other category is custom fabrication. So you get projects from single-family houses to, multi-type buildings that are the result of architects trying to thwart the mass customization system and create new ways of doing things, from the scale of inventing a new material, inventing a new formal language, and creating a new process or method for installing or assembling that thing. With those two realities on the table, I think what would be really exciting moving into the future is if we can sort of assimilate the best properties of both of these methods of working, where you still hold on to the positive qualities of a mass production framework, where you allow for the productization of building technologies and the standardization of building technologies that enable really smart, safe, resilient materials, structures, components to be built, largely off-site, but even potentially on-site. But then you also leverage what custom fabrication offers, which is the bespoke aspects of every building that make it site-specific and make it a rich space. Make it a space that solves specific programmatic problems that probably couldn't be solved otherwise. And I think that's what's exciting to me about what we're talking about, is like trying to bring a convergence of these things together so that we can create a kind of building that leverages both of these ways of working.
Yeah, I think that notion of the kind of two properties always comes down to the question of money, ultimately. And so what I've typically seen in my work is that you come up with a custom facade, for instance, and then someone else says, well, I can do 3 custom pieces rather than 50 custom pieces, and I can do it for a significantly lower cost. But I think one of the ways that architects can try to push that is to put it into the contract documents or create processes or specifications that require the kind of custom fabrication. In my experience, the firm that I worked at, we actually had to come up with a custom 3D probing exercise on a robot to prove that one fabricator could do a better job than the other. Do you guys see any of that being introduced into contracts that you've been working on projects? Specifications for specific programs, we've talked about BIM a little bit, or just general requirements for the fabrication process itself?
Yes, we have a number of projects, one currently in New York City that does have BIM as a requirement. Where it falls short, again, I think comes down to what you mentioned of cost. That there are some sub-trades that have the training to be operating in BIM and are comfortable in BIM, but they are underbid by some subcontractors who do not have those technical skills. And until it's really embraced, it just all starts to fall apart. You're only as strong as your weakest link in that scenario, which is something that's very frustrating. On this specific example, we had a scope where we've been updating BIM regularly and keeping everything in there, but quickly realized we were the only ones doing that. And when we showed up on site, things were not as we expected. And the answer we got is, well, that's the reality of it, is that these people didn't know how to use BIM, so we didn't make them. And it's a tough hurdle to get over.
Yeah, I think it's a particularly interesting question relative to the subject of assembly. When Skylar gave his opening talk, one of the things he mentioned was, in the world of mass customization, the intelligence of the system often comes to a grinding halt in the world of assembly, because you've got these individual custom things that maybe were made really smartly with robots that don't care what the shape is, they just make the same thing, turn a weird thing out, or a non-Euclidean geometry as fast as a Euclidean geometry, and the efficiency doesn't change. But the reality is, when you have all these unique shapes and you have to assemble them, we're just clumsy people. And to come up with a set of instructions to give to someone else who's used to putting rectilinear things together is a very, very difficult problem. And so relative to your question, Max, I think what's really interesting is there are a number of companies that are surfacing that are working on using technologies like AR to inform how the assembly process can work. There's a company that's specifically has been focused on bricklaying and looking at just a simple rectilinear unit, and the concept that, well, what if we could lay bricks in a manner where every brick gets a unique rotation in the XY plane? Very simple, we can all understand the basic concept, but when you stack these bricks up to make a wall, it creates something sculpturally that has never been made before and will likely never be made again. And the way it can be made is the assembler sticks on a headset, and every time they lay that brick down, it tells them the degree of rotation, and they get visual feedback to confirm that that rotation is accurate. So you get quality control, you get safety, and you get an enormous amount of intelligence and speed by integrating these technologies and kind of collapsing them around the assembly process. And I think it will enable new kinds of construction that we haven't seen before as these technologies advance.
Great. I think related to that notion of labor, another dichotomy that we often hear about is between the future of on-site construction versus prefabrication systems. Some, like Warren Buffett, celebrate pushing the construction process more towards the automobile manufacturing process. We've also similarly seen ventures like Katerra fail rather spectacularly. At the same time, on-site automation still seems to be clashing with field tolerances and other unforeseen field conditions. Do you think we'll see the industry evolve along a more horizontal axis of specialized fabricators, or into a more vertically integrated process with fabricators who can automate the process from design all the way through construction and operation?
I think that it's actually happening in both directions. With a more vertical approach, like what Katerra was trying to achieve, I think it's just going to take a lot of time. And in my opinion, I think it's something that will require evolution, and it will be probably a decade before we see a successful in that kind of scale. On the other side, I think that we are definitely expanding in a more horizontal approach, where we are generating more specific trades, and each of those more specific traits are learning how to communicate with each other more efficiently, and the communication between traits results in less conflicts on site, and essentially overall it's just going to lower the cost of the project. Of course, you have examples like the one you just described, where not everyone in the construction project is involved at the same level.
Yes, absolutely. My comment on that would just be, and it leads to the question asked earlier about smart cities and leaving other areas behind. I think that's something we see a lot in the construction industry, is that there are custom fabricators and architects and other trades that are using technology to the fullest and really accelerating, but it is at a rate so quickly that it's leaving the trades on site behind. And I think that's an industry that needs to be brought up to speed. I think it'll be really great for all parties involved. We need to start getting that technology applied on site, whether it's through the HoloLens or other digital management tools, because as Matt just mentioned, trying to put these incredible shapes and designs to people who really only are provided the tools to build rectilinear projects is incredibly difficult. It's how do you take these things where you can spin around and you can reference a world axis to someone who's really only given a laser level and a tape measure, which is the reality of it. That's going to be the tools that anybody has.
So I think the notion of transparency there is super important. I think we've talked mostly so far about the kind of relationship of this information moving between the project team. But I'm curious, we had Philip Block give a lecture recently where he actually proposed that the construction industry won't be able to fix all of the issues that it's going to have, and the only response is that fabricators and contractors need to start working together and actually open source all of their proprietary technology. But at the same time, we are in a place where everyone wants to kind of own that ownership, and so we're not really sharing among different firms. So between Branch and C.W. Keller, I imagine there might be difficulty sharing some of the solutions you come up with. Where do you think the field is going in that direction? In computer science, there's a big push towards this kind of open source model, but it seems the construction industry kind of has an antithesis to that.
Yeah, I think it's an interesting question. I think if you look at recent history of Chinese technologies, I think taking a lot of information, intellectual property from US companies, and intellectual property moving across borders, I think it's a lot of the issues surrounding the question are cultural issues of what is the culture of how you use information and how you share. They're just the concept of sharing. And as soon as you make something open source, well, to what extent is it open source? Anything that's open source still has levels of open sourceness, if you will. And so I think that's pretty interesting. I do think that there are certainly values, and I'm speaking from on behalf of Branch because we have, I would say, a considerable amount of intellectual property that we have protected through patents, both in patents that we've secured both domestically and internationally, and patents that are currently in process. But I have found, and I was not someone that was initially convinced that it would be as valuable as I've seen it to be, that it has been purposeful in the sense that we found that by being able to carve out a portion of intellectual property around a process or the way a material is used or a technology. For instance, we have a patent around the particular kind of extruder that we use to extrude our polymers. We've been able to bring partners into that conversation around how to advance that technology in a far more productive way and expeditious way than I feel like we would have been had it been more open source. Now, that doesn't mean that I'm totally pro, keeping things locked up in a vault. Even if we try, we're not. That system does have failure modes, but I do find that both methods have their pros and cons. To your previous question, if I could just address that a little bit, because it's super fascinating to me, and I think a really important question about the relationship between generalists and specialists relative to construction and automation and things like that. I think a picture that helps me a lot is to think about a tree. Oftentimes we talk about how root systems of trees generally mimic what we see above ground, below ground. And I think that if you think about time moving from the ground level down into the earth, we were maybe in the 20th century closer to the surface, where the splinters of subcultures of specialists were somewhat limited. But then as the internet became more global and information became more available and we were able to share that information more and more subcultures of specialists and more positions that had never been conceived became real. And I think that's really interesting on so many levels. An important one is just that as a result, I think you will always have generalists. Companies like Turner Construction, Saint-Gobain, another one I was thinking of a moment ago that is not on the tip of my tongue, but these companies that specialize, their specialty is in construction, which is a massive field that covers so many different disciplines. But then you will also have C.W. Kellers and Zayners and custom fabricators that are so focused in on specific areas that they will ultimately inform how the generalists operate. I think what's the important lesson to learn, in my opinion, is that the scale is changing. That if you take the relationship between the generalist and the specialist 50 years ago, there were still generalists and specialists, but the amount of specialists from a volume standpoint was far fewer. And so the capacity for the generalist to reach into all disciplines that sort of affect its industry is becoming more and more difficult. And I think that's exciting in one respect because we're able to innovate in so many different areas of life. It's just a question of how we then communicate between them.
Also, I want to add a note in the previous question. I see two branches emerging. One is essentially where you have the architect thinking of itself more as the master mason, or back in history where the architect was on the field every day telling the construction builders how to essentially operate the machines or how to develop new technologies to be able to generate the specific geometries. Back in Puerto Rico, for example, there's a lot of architects that, or coming from an architecture background, that they're starting their own building or fabrication companies. So I'm seeing a lot of people going back to that, where they are both the designers, but also offer the solution to essentially fabricate this particular piece, or have a construction company that will allow you to have just a one-stop shop. On the other side, there's companies like C.W. Keller, Cora Stone, Branch, where there are very specific techniques and very specific materials, for example, in this case, where they are going to architecture schools and hiring architects that have the training and the knowledge and the three-dimensional understanding of how to operate this new equipment and how to operate the software to generate these geometries.
Yeah, I think those are great points. I think related to that question, where do you see the role of the architect going? Because it's easy to understand an architect that moves into fabrication and develops some kind of specialty. But I guess really if we're pushing that, there is going to be more specialists, but the architect still has to maintain some level of general knowledge to be able to move multiple projects forward. Do you think it'll be more that architecture firms become more specialized and work with very particular construction systems, whether that be CLT, mass timber, or 3D printing with concrete? Or do you think it's something that the architects will maintain the kind of generalist knowledge but try to engage some of these fabrication companies earlier? Greg, as you mentioned earlier, if you can get in before they have a Rhino model, you can help guide them through the kind of material and logistical issues with whatever you're going to fabricate.
I think that would be a great way for it to go. I do think that architects need to have a pretty general knowledge, because the reality is that they are going to be working in multiple materials, and just because they want some ornate millwork in the entryway does not mean that the rest of the building needs that same understanding of custom millwork. So I think it will go that direction, where they have a general understanding so that what they've designed is potentially achievable. Obviously, they will always continue to push the boundaries. But rather than trying to pencil down at some point, I think will be important. And then approaching the experts for specific areas and those specialists where needed early on will be invaluable.
I think the climate we're in right now is particularly challenging because on the one hand, I think architects, developers, even general contractors are looking to specialize because they want to have competitive advantage. But at the same time, you don't want to become too niche in your expertise because you need to diversify such that in an economic climate like the one we're in, you can remain afloat and you can be sufficiently agile to work in different building types, in different climates and things like that. So it will be interesting to see how this evolves. I can only imagine that it will be to the advantage of architects to find degrees of specialization regardless of their size, and to be able to cultivate those specialties for their own competitive advantage. It seems like there is a threshold over which people are constantly navigating, where they're fighting, wanting to keep that competitive advantage on the one hand, but also to make sure that they're sufficiently diversified so that they can remain afloat in uncertain times.
Great. I think we have a couple other questions we could go over, but I'd also like to give the chance to have anyone from the crowd ask a couple questions. We'd like to give the crowd an opportunity to ask any questions.
Going back to the theme of the conference, is there something that you do that is now different due to the acceleration in the technology adoption that we heard about earlier from the previous panels?
I mean, the elephant in the room is always remote work. Our company ended up acquiring an entirely second facility and doubling the size of our company during the pandemic. We opened up a facility in Colorado. It went from a little over 40 employees to over 110. I myself relocated from New Hampshire to New York. But I think what I like to see from that is that through learning how to communicate internally since the pandemic, it's really sort of driven everyone to be comfortable and be transparent between trades, like we talked about. We may not have jumped on a video call with the architect once a week before, and I think that was a nice platform to kind of force collaboration, and it seems to have really stuck.
Yeah, one of the things that we sort of joke about is the idea of a lights-out factory, meaning, we at Branch we work with large industrial robots that are supposed to be automated, right? And we talk to clients all the time that say, "Oh, you 3D print stuff, so the degree of accuracy is infinite, right? Like you print things that are essentially perfect. They come straight out of the computer and they're flawless." And the reality is it's still very early in the development of a lot of these technologies, and we make stuff that's very messy and requires a lot of handwork in many instances, as I'm sure everybody here will attest to. So the reality is we kind of use that as a sounding board and a reality check to ask ourselves, well, where are we in the development of truly automating processes and reacting to the consequences of an attempt to engage with automation in that way. We were talking the other day about just this issue of safety within labor. So, with automation, one of the goals in automating a task is to make it more safe. But the reality is, in a lot of the automation I'm involved with, is you're actually creating new safety concerns by engaging with a certain level of automation. If you have a large industrial robot that can kill someone by skewering them with an extruder that's made out of steel or aluminum or whatever, then you have to create things like what's called a light curtain. So it's a sensor shell that wraps around the robot. So anybody that walks into that space, the whole thing shuts down because it's a huge safety concern. We have a milling robot. So we put a giant drill bit into the robot's end effector, and it drills 12-inch long bits into industrial materials. You don't want to be in there at the same time the robot is doing that. So we have huge new concerns around safety to make these sort of custom operations that you can't predict. In the 20th century, the machine was doing the same thing over and over and over again. So how you design safety around those kinds of operations is much more straightforward. But if every time the robot's interacting with material, it's doing something you've never seen it do before, now you have to be, there's an exponential increase in the solution around how you create a safe environment and a working environment that's efficient and materially sensitive and all of these other things. So that's been a big issue for us. And reacting to the pandemic in specific and just thinking about how can we do better at imagining how we're going to engage with automation in a way that allows us to do both remote work and engaging with one another and with the systems we're creating remotely, but also recognizing the absolute criticality of being there in person and holding the materials with our hands and interacting with the machines with our bodies.
Matt, I couldn't agree more with you when you talk about the client or the designers thinking that we're going to 3D print this thing, so it's going to be perfect when it comes out of the 3D print. So that actually it's one thing that we see in every project that we work on is that doesn't matter the material that we work or the geometry or the methodology, it's going to pass through human hands. So like the robot, it's not perfect. The accuracy of the arms it's not designed for some of the accuracies that these projects require. So there's always going to be some sort of finishing process to that project. So that's a space for automation that, in my case, in my company, the most time-consuming process for every project is finishes. Either it's wood or it's metal or it's any other material, for example. It will require us to essentially have everyone on board sanding, spraying polyurethane or something like that to finish the piece. But this is something that it's not really being thought about, or what are these automation processes could help us minimize the amount of time that we spend finishing these pieces, and how is that going to react with the cost of the project?
I'd like to reiterate on one of Matt's points. My anxiety has gone through the roof since we've acquired the robot here that we also have a spindle on, and now we're giving it to freshmen and sophomores to operate for the first time, hoping it doesn't impale anyone. Do we have any other questions up there in the white?
Good afternoon. Thank you so much to this panel. I have a question. Do you think government facilitates 3D printing solutions? And do you see any increase in state funding in that area? Or where you get your main funding? Thank you.
Did you hear that? I think the question was, are you seeing an increase in the kind of government interest in 3D printing? And is that leading to kind of grants that is providing funding? Or where are you getting the funding for the kind of automation processes you're trying to incorporate?
I can talk about that. So the 3D printing of clay corals that we're doing in Puerto Rico, that was actually funded through the EDA. So it's actually a federal grant that allows us to essentially prototype that project. So that particular project, it's in a scale where it was possible because of the federal grant for the prototyping phase, but now it has opened up for investors. And for example, one of these pieces are 14 inches by 14 inches by 10 inches tall. And to have an actual impact on the environment, one of the case studies that we're looking to develop, it will require 30,000 pieces. So, for example, 3D printing, it's probably not the best methodology for a project of this scale. So there's definitely, I think that there's definitely a lot of interest in 3D printing technology, especially in the government and more resilient solutions for construction. But I think that we have to be practical when we're implementing these solutions.
I think it's very interesting because I think with most manufacturing, you have panels of 3 people in manufacturing, they would say that there's no way 3D printing can compete. But being on a panel with all custom fabricators, I think is one of the few places where it really does. I think it can excel because its limitations is that it's not great at producing the same part quickly. It will never be traditional manufacturing, but it is much better at creating one thing that's unique as a one-off and not wasting cost.
I mean, the reason that we ended up using 3D printing for this particular project is that it allows us to just go through a bunch of prototypes in a week.
Yeah, I would say we've as a company have definitely seen considerable interest from the government and government agencies in additive manufacturing. We've gotten contracts from the National Science Foundation, from the U.S. Air Force. As I mentioned, we're doing work with NASA. One of the projects we're working on is how to print with the moon's native material. It's called regolith. So using a regolith-based material to print on a lunar surface. I think that relative to branch, we sort of have a few different verticals. We have government-related contracts that include military and otherwise. We have private contracts, and then we also have investing. So we're a privately owned, venture-backed company So we have a lot of investors that believe alongside of us that additive manufacturing as a way to inform, in particular, building facades, has a future that will compete with traditional methods of manufacturing.
Am I to understand you received a box of moon material?
Oh, yeah, one of our goals is to work with NASA and a few other partners to print with native lunar material. So the idea would be basically that you would send 3D printing robots to the moon, but you wouldn't want to send an enormous amount of material with them because that would be silly, right? So how could you potentially print with native material, either using a foreign binder or a composition of foreign and local binders? So yeah, there is interest.
Great. I think we have time for one more question. Nope, we ran out of time.
Thank you so much. Thank you.
And now we wrap up the afternoon with exciting plenary from Margaret. Please stay with us. So, Margaret Brisbane is the director of the Information Technology Department for Miami-Dade County. Prior to joining the county, Margaret served as director of service delivery for Burger King Corporation. During her 20-year career, she led the Telecommunications Center of Excellence for various Diageo, did I pronounce it? Diageo brand, and worked on restaurant systems support as well as point-of-sale systems implementation for various domestic and international locations. Please join me in welcoming Margaret.
Well, I can tell you that building presentation was rather interesting. Not my field, but I can tell you it. I almost want to go on a trip to the moon to collect all this material to be building all this stuff. It sounds rather interesting. So again, I'm Margaret Brisbane, and I am the CIO for Miami-Dade County. And I listened to you know, kind of my Burger King days, and it seems like such a distant memory because I've been at the county for 16 years and just doing so many phenomenal things. So how do we fit into this world of smart city? I can tell you Miami-Dade County is one of the most progressive counties. You know, I just saw our colleagues from Coral Gables, and they're doing so many interesting projects which really uses the technology like the GIS Foundation that we have built. And the good part about this is that we're building this smart city together. We are not doing it as fragmented municipal governments, and I think that will be beneficial to our citizens as well as to the community in which we live. So let's get started, and I will go through this fairly quickly. I don't need to educate you guys on smart city, but you know, it's all about driving efficiency. As I say, anything we do regarding county operations, we're looking at how do we do it better than we have it today. Creating transparency, how do we work together? You know, a lot of what our, you know, the panel spoke about is the use of data. And that's what we build everything on. We use data as a source of building all the solutions that we're putting in place across the county. And of course, having an inclusive type of team to work on, you know, the projects that we do, because the goal here is to make the lives of our citizens better than it is today. So let's talk about a few of these areas that the county is really focused on when we think of smart city. Mobility. You guys all live here and know that traffic is horrible. I don't have to tell you that. But at the end of the day, we are looking at how do we improve that over time. And if you guys thought about 2 years ago, many of you didn't drive anywhere. You didn't take the train anywhere. So when we looked at usage in transportation, it took a deep dive because people just weren't going anywhere. They stayed at home. I can tell you that that's absolutely on the uptick, and so mobility has never been something that's not been on the minds of our transportation folks, whether it's, regular transportation department or port or airport, it's always been top of mind. So as we look at what we're doing in that area, I'll talk a bit more about that. Again, connectivity. Connectivity is about how do we ensure that there's digital equity for citizens. As we look at coverage for broadband, I would say 70% of our citizens have broadband access. So we'll talk about what we're doing in that area as well. Climate and environment, a top consideration in Miami-Dade County. We just had our climate summit here, and I'll just tell you a bit about kind of some of the focus there. And where are we heading in the future? We need to look at all the things like Internet of Things, and we'll talk about how we're going to be using all of this technology to get information, to make better decisions. And of course, who can ever forget the blockchain cryptocurrency world? This morning I participated in a conversation with nonprofits trying to figure out how do we get people to donate cryptocurrency to us and stocks to us. So, it's all sectors of our community. So let's talk a bit about mobility. The county has a very long-range plan for all things in the mobility sector. Right now, we're building the South Dade corridor that takes us from here all the way to Homestead. People voted for a tax that they thought would ultimately result in a train. It's really not going to be a train, and so there is citizen concern about that. But this corridor is being built to connect from the Metro Rail all the way to South Dade. I'm using electric buses, so there's also a big concern about the environment and what are we doing to ensure that as a county we are very conscious of having an environment that is not being polluted. So these electric buses will surely do that. We're also putting in sensors. We have 27 or I think this 2,900 intersections, and we are all of them will be changed out to sensors that have, enough intelligence that we can gather information. Can we automatically change the lights when the buses are coming through? So it's how do we use the information that we're going to be getting from these sensors to improve the traffic flow and to gather information. Can we use these? They all have cameras built in. Can we read license plate and figure out when cars are stolen? So how do you just make the entire environment that you're building smarter so we can gather information to make better decisions in county government? Again, automating everything. We have mobile apps for everything. We can tell you when buses are coming, when trains are coming, how long it will take them before they get to a station. So, there's all of that has been in place for years, as well as just the ability to pay for services. I went to a store yesterday and someone tried to pay with cash and they said there was no cashier available to take cash, So everything needs to be tap and go. People don't have, don't walk around with money. I guess after COVID, nobody went anywhere and shopped. And so, they just don't have cash in their pockets. Everything is, Apple Pay, and everything just needs to be automated in a way. Looking at, the connectivity, it's that last mile. I get off the bus, I get off the train, how do I get home? So lots of collaboration with other partners to say, let's make it a seamless transportation option for our citizens. So access. As I said, there needs to be digital equity. We are now in the midst of a project where we are looking at, what do we do as a county to ensure that the underserved areas are really getting the coverage they need. The state started a project with all 67 municipal governments to really ask the question, what are you doing? And so we have been working really closely with several partners to look at what can the county do. We are not a service provider, but we understand the importance of connectivity. During COVID, I can tell you our libraries were used to the maximum because our Wi-Fi in the libraries extend out to the parking lot. So how many families ended up in the parking lot of a library getting homework done because they didn't have internet at home? As well as we got into the business of loaning laptops. So you check out a book, you can check out a laptop, and it comes with its own hotspot and everything. So a kid comes in, or a parent who is doing online classes or trying to learn a skill, they can get equipment from our public libraries. So I think COVID really brought out that inequity, and we have been working really hard to try to bridge that gap. And again, I think access should be as ubiquitous as water and electricity. So hopefully we'll get there at some point. Online services. During that 2 years of COVID, I am sure everyone just wanted all the services at their fingertips. I don't want to go to a bank. I don't want to go to a government building. And so we, as a Miami-Dade County, were really forced to say, what services are we offering where we are asking people to come into a building, but we really could make this transaction online and much easier for citizens? So we have done a significant job of putting services online. Today, we collect $2 billion in online commerce. Do you want to renew license? Do you want to, do rabies tags, renew a license for your animal? All of that stuff, everything is online. And also, where people would pay in checks and stuff, we made all of those services really online services. You pay with a credit card or an e-check. And that it went from $500,000 to $2 billion in less than 10 years. So that's the services people want. We need to provide county services to our residents where they are and when they want it. And that's what we're working to do. Open data. I can tell you that this is an area that we have seen just such a growth in terms of demand. And it's not just from people wanting to know, environmentalists, let's see all the maps you have on sea level rise. Let's look at everything happening in Biscayne Bay. We maintain close to 1,000 layers within our GIS system of everything you can think of within this county. So when we need to do a report on the Biscayne Bay, all of that information on sea level rise and vegetation, it's all already in our GIS layers. Our climate summit that we just had here, again, all of that information readily available. So we have an open data portal that any information you want that's there, there's no charge, it's free, you can go and get it. Many universities tap into that information and use it for projects. So again, we keep that updated on a regular basis so folks have access to county data. Smart buildings. Many of our buildings aren't that smart. And so we are really working to ensure that we can upgrade our county facilities and consolidate a lot of our county facilities. We are now working in a hybrid manner. In my department, I have 940 IT professionals, and I would say 20 to 30% of them may come into the office a few days a week. The rest have not seen that office in 2 years. And guess what? Work still gets done. and they are really productive. And so we do not anticipate that we will get to the point where I will ever bring all the employees back to the office. The expectation is that we will remodel our office to make it a hoteling location where people can check in if they're coming. If, you know, my GIS team wants to come in for a day, then they can reserve space and they can all be there. The same for document management folks or asset management folks. The people who are there every day are our HR staff. They're in the office every day. Our administrative staff that do procurement and finance, they rotate the days they're there. And our division that comes to work every day are the guys who work in my radio shop. They install radios, computers, and light bars on police cars. I think we have 200 cars we have to get done in a few months, so they are there all the time working. So, and our field services folks that support all our offices are there as well. As I said, sensors are a big thing. I can tell you we have vendors knocking on our door every day trying to sell a sensor that measures heat and water and, you know, humidity. I mean, there are sensors for everything. So, you know, the mayor appointed a chief heat officer, and so that's a big thing. You know, who lives in the areas that are more impacted by heat? And is it because we don't have enough vegetation there? There's a lot of studies about, you know, the whats and the whys and how do you address that. Sea level rise, another big area in terms of what's happening. We had the Aspen Climate Conference, and I can tell you, I sat in a meeting at the port where 5 CEOs from the major cruise lines had a conversation about what they're doing. You know, shore power is a big thing, so when cruise ships come in, they plug into shore power, and they are not emitting as much methane or whatever they emit from a cruise ship, but it's all about your environment. Everyone has a responsibility. And so, you know, the mayor is creating a pact with these cruise lines that say, what are you doing to ensure that you are doing what's positive for the environment? And it was a very good conversation, and the commitment is there. But, you know, as with everything, some of those ships are old. Shore power is not something they can convert to, so over time they'll have to replace these ships and get newer ships. So with technology, sometimes that's the case as well. It's too old, we can't do much about it except replace it. So, you know, I'm sure changing a cruise ship is much different than a computer, but, you know, over time they will evolve to more efficient cruise ships. So where are we headed? As I said, Miami-Dade County is really one of those counties with a mayor. And if any of you guys know Mayor Daniela Levine Carver, she doesn't sleep. She's always on the ball looking for what's next and what are you doing. She reads everything. She just did a trade mission to Israel, and I think she came back with a list yay long. Margaret, have you talked to this company? Do you know about this technology? I mean, the list was just endless for me. And so we truly have to be very focused on not just today, but as we'd like to say, we need to be future ready. And so we are always looking at what are the technologies that we need to incorporate into our portfolio that will make us ready. We talked about sensors, absolutely need to look at that. Looking at systems that are fully integrated, so we are not replicating information from system to system, but sharing data. We are very much into creating dashboards for everything, and it is very important for leaders to understand that this is data that they can depend on to make decisions. So, you know, from a credibility standpoint, we have a few folks that would like to check and double check and triple check information before they will say, I believe this. But the good thing is that we are pulling information from source systems. And so I think the level of confidence in terms of this dashboard is telling me this story, And this is what happened 5 years ago, a year ago, and so I can depend on it to predict where I'm going and to make some decisions. So we used our dashboard quite a bit during when you thought of CARES dollars coming through COVID. You know, the county got all $467 million for COVID relief. Not just for the county, it was meant for the county and municipalities. But they never gave it to any municipality because they were too small. So the county became the stewards of the dollars. And so we created, I would say, a dozen programs helping folks with rent, helping with taxi and jitney services. We created boxes for small business with all the components they needed, whether it was masks and sanitizers. So it was all these things that were needed to get business back on track. What we ended up doing was then reporting to every municipality how much was spent in their district. And so there was, again, transparency and trust that although the county was the stewards of the dollars, every municipal government knew how much was spent. And guess what? It was easy to say, see, we have $27 million for housing assistance, and in your area, your residents are not applying for this. And so it really allowed them to promote many of the programs where there were dollars to be had. And so I think, you know, having to report on that on a regular basis gave them confidence that, you know, at least they knew what was happening and they couldn't say, I never got any money. We told you, you have the money, you just haven't tapped into it. So, you know, those were really good dashboards to present every week. Artificial intelligence, I can tell you we are constantly evaluating how we can use that. Virtual reality, we have 268 parks in the Miami-Dade County portfolio. And one of the things we realize is that people don't know enough about our parks. And so we hired a guy who worked for National Geographic that retired and just loved parks. He came and did all these amazing photography of some of our parks, and we combined it with GIS to create a virtual experience. So if you wanted to see what park could I possibly get married and they had a water feature there, you could actually look that up. We brought in historical pictures. We did one of Grinnell's Park, which is in the north. The Tequesta River runs by this park, and it has canoeing. And so we had pictures where people were getting married there in the 1950s, and so we were able to showcase that type of stuff all through a virtual tour. So trying to figure out how do we use these technologies to really engage people with county services. As I say, blockchain, crypto, NFT, definitely on our radar, looking for the applicability of that in county government. We truly have to be very prudent with our work because we need to make sure that we are ready with the back-end systems from an audit perspective. And so we are constantly working on that. And again, all of these things together is what makes us move in the direction of becoming a smarter city than we were. So I speed through this because I'm the only person between you and a drink. And so I just didn't want any of you guys falling asleep on me. So this is really to give you that snapshot. Feel free, connect with me on LinkedIn if you want to just learn more about what the county is doing. If you want to get plugged into some of the things that we're working on, by all means. We're all about collaboration. So I thank you very much for your time, your patience, your attention. And it's a pleasure to be here with you. Thank you.
Do you mind taking
Oh, absolutely.
questions?
Any questions? I see you there, Sheikh. Go ahead. Oh, I love that.
Of the network, especially in a place like Miami or Miami-Dade County that's prone to hurricanes and issues? Are there any policies, action plans, or backups in case technology and internet fails?
We have disaster recovery plans out our wazoo. We've had this for many, many years, and so all our critical business put together we have a disaster recovery plan for all IT. We have 2 data centers and a backup location, so all our critical systems are in one or several of those buildings, and many of our critical systems are in cloud. So I can pay my employees, I can pay my vendors, and my asset management system, which becomes really important after a hurricane when buildings are damaged and trees are down, and we need work orders to get stuff done. That's redundant in several locations. So again, we have exercised this over many years, and we also have food plans, business recovery plans, so employees and every department knows if a system is not available, can I do my work in a manual manner? So everyone has to revise their food plan every year, and we just had to submit them also. We are ready for the hurricane season when it comes. I hope it doesn't come this year, but we're always ready.
Awesome. Thank you.
Our employees are all trained to work at shelters. In my group, 230 of my employees are assigned to shelters, and so they get trained every year. But in the county, 2,200 county employees work at shelters every year. Not the most fun job, but civil servants, that's what we do. Yes. Well, we have a team of 44 people that work in our cyber security team. And I can tell you, they have relationships with every 3-letter agency there is. We do have a managed service for cybersecurity that monitors the county 7/24. We have an incident command team that if anything is even looking suspicious, they investigate and determine if it's something that we need to be concerned about. I can tell you the county has, I would say, one of the better cybersecurity programs there is, because these guys are really focused on protecting the data, the citizens, the systems, and they are on the ball at all times. We are now working with our water and sewer department to look at, our SCADA systems. We know what happened in northern Florida, where, if someone hadn't caught the issue with the water, the water levels, people could have died. And so we really are very focused on working with our water and sewer team to ensure that all our water plants are well protected. And so we bring in cybersecurity companies like NIST to do tabletop exercises with our companies. We're also working with our colleges. Miami-Dade College now just recently launched and opened their new cybersecurity center. And so we will be working with them to do tabletop exercises specifically around county operations. Any other questions?
Thank you.
Margaret. So I remind you that we are back here tomorrow for 3 more panel discussions, starting at 9, correct? But by the way, speaking of the schedule, I remind you that you can download the program by scanning the QR code on your right there. And now I invite you to join us for the reception and the exhibition across the breezeway in the Courage Gallery. Thank you for being with us today, and we hope to see you again tomorrow. Thank you.